YouTube. Check. Can I see all of my wonderful shit? No, Tarek, you had to fault me. I was just checking all systems are go. That's my PC in case anyone's wondering. Here I thought I had all systems go, and you ruined it for me. Hi everyone, welcome in, welcome in. I hope you guys are keeping well. I will say hello in just 2 seconds. Streamlabs chatbot is being booted up at the moment so that our sound alerts are all functioning. There we go. Hi Vesbanana, Talon, Tarek, Slay, Harry, Zir, Seribot, Herder, Dan. I think I got everyone. There we go. Hello, hello, welcome in, welcome in. Happy frickin' Sunday. Hello, Faceless Prophet. Do you good? Hope you guys are keeping well. I had another comment on my YouTube video, the new one, the advice about physics lessons, pop up, asking, what does learning off mean? And I realized that, because someone asked it in the chat yesterday, I was like, oh, this is an Irish phrase. This is something that I thought everyone knew, and it turns out they don't. The internet is a very interesting place. Hi, Lind. Welcome in, welcome in. Oh, look at those IQs. Some very questionable IQs. Sorry, cleaning side of my mouth. Welcome in, everyone. Happy Sunday. Happy to have all of yous here. What are we doing today? Yes, we are building our speed of sound measurement device. That's the plan today. Today is a speed of sound measurement device. I am very hopeful that this is the one. I have chosen a lid design that I'm happy with. What's on the shirt? It is the Schrödinger equation. This is the general form of it. And it's a cat in a box. And if you look behind, it's also the back of the fluffy cat. It's part of my merch. We released it almost 2 years ago, I think. Medjay drew the artwork for it. Is that the link? Yeah, there you go. It's on there somewhere. Hopefully we'll have some new interesting ideas coming up this summer. And applied reinforcements learning to... That's pretty fancy. That's pretty fancy indeed. Hope you had a good time with that. Hi, Herc. Welcome in. Let me put on some moisturizer. It has come the season that my allergies on my fingers break out more than ever before. Fist bump. Pump my fist. Bump my fist even. To all those who also have metal allergies. We are suffering together. Hi, welcome in, welcome in. Happy Sunday indeed. I guess there's nothing stopping me from chatting and immediately get cracking. To work. Fist my bump indeed. I mean, there's so many amazing quotes from that one-liners, you know? Obviously, fist my bump, amaze, 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 and 3 of them. Oh, just, I suppose, doing that the whole time for good things. But it is what it is. Oh, I need a ruler. There we go. And we'll boot up Tinkercad. I was just looking at Thingiverse and I saw a whole bunch of catapult designs and I thought, oh, a catapult in the classroom sounds like a great idea for teaching projectile motion, and it would be cool to record a video of it into slow-mo and showing how, do you know the way if something is thrown that its vertical axis is no different than if something was just dropped straight down? It would be really, really cool to do those demos in class. But then I thought, you're bringing a catapult into your lecture. I am asking for trouble. I am asking for trouble. But it's still on my radar. I might think about it again. Hi, Tetsu. My music might be a little bit loud, let me know. It's not very relaxing. If anything, it's It's Mass Effect OST. I'm going to put on Surviving Mars OST. That's also not very relaxing, but I love that soundtrack. What size catapult? Oh, about this size. It's not crazy. Not too crazy. An apple and a bow would work really well too. We're just asking for trouble, let's be honest. So yeah, anyways, that's a 3D printing project maybe. There's another simple 3D printing project I want to do. And that is I want to build where was my train of thought going? Ah, yes, this kind of it's to teach it's to teach entropy really, but it's this like little grid thing to teach statistical physics. It kind of looks like 6 egg cartons on one side and 6 egg cartons on the other, and then you have 6 balls, and you keep shaking it in the cartons, and then open it up, and the 6 balls will sort themselves out in a certain way. So obviously, we know that heat travels from hot to cold. But what are the chances that all 6 balls will be in an ordered side on the other side? So it's a kind of nice demonstration on statistical physics and of course entropy. Now obviously we don't have just 6 gas particles, we have millions, so imagine what the probability of it is going the other way. 2 seconds. Nate, is everything okay?
Yeah, yes.
Oh, okay. Sorry, in case you're hearing banging. There's no one breaking into the house, it's just Nathan. Hi, Star. Welcome in. Hello, Dr. Prince Bones. I guess the catapult is a good first step towards the trebuchet. That's true. That's true. Maybe it's, you know, if your projectile. So the problem is, my thought process with the projectile is that it has to be quite air resistant. The thing that I'm projecting, because you want to be able to show. You can't have air resistance being too huge of a factor, so we do need it to be quite, you know. Anyways, that's another problem for another day. We don't need any more projects, chat. We don't need any more projects. But there is a thought over summer that, you know, I'll be teaching electronic devices and systems, and I'll be teaching classical mechanics in next year. So, like next semester year. So if there are ideas for demonstrations that we could build and 3D print and design, do not hesitate to shout out. Maybe a cork? I would say a cork is quite... Yeah, I'd say it's quite air. You could use Nerf gun ammo. I need to see what it looks like. Hi, Johnny. I was thinking of projecting like a metal ball or a super dense plastic ball. That's what I was thinking. But obviously not projecting or hitting the students. But I feel like, yeah, still. Anyways, hi Herder, how are you keeping? I hope you're keeping well. So we're going to work on our speed of sound measurement device immediately, in case anyone's wondering. I don't know what the size of my thing is, but I definitely know it's bigger than this. This is a very strange phrase to say out of context, but you get me, right? A coil gun would be... Is that the electromagnetic one that you're referring to? We did look into years ago, when I first started demos and stuff. We looked into a rail gun, and you can kind of build a little demo of a rail gun. Is that the same thing that you're thinking? No, I think we need to start from the start here, unfortunately. All right. Start with a new design. The first design we're going to start is with a box. Every good story starts with a box. So this is all the electronics I need to fit in. Space do I really need? we want it to be a tall box. So something that we noticed, the problem with one of the boxes is that it's too, the speed of sound measurement device ends up measuring too much of the table, because you can imagine that ultrasonic sensor operates like a cone. So we need to kind of give some height to it. This is what a Nerf gun ammo looks like. Okay, let me have a quick look. That would work with a crossbow projectile. I don't know about a catapult. Like, I'm talking about a tiny thing. Like, on this catapult, I need something spherical and small, you know? We could redesign the catapult then specifically for Nerf guns. Yes. Oh my god, my octopus caught things. I have the LCD. There. Height are we thinking? We're thinking about 20 centimeters in height, maybe? About 20 centimeters in height sounds good, yeah. 20 centimeters. That's quite tall. That's my PC, don't worry about it, chat. Oh no, my ruler shattered! Oh my god, I've had this ruler since I was a teenager. Damn, it has like Planck's constant and everything. It lasted so many years. See, this was, okay, teenager is a stretch. I was 19. Oh no, I wasn't. I was 22 years old when I got this. I'm a liar. I was 22 years old. It was my first conference as a PhD student. No. Little corner. Oh well. Oh no, 20 centimeters is massive. 15 is plenty. 15 might be a big. But we'll do 15 centimeters in height. And then maybe 10, 10. 10, 10, 15. There we go. Quick, get the duct tape. I have PVA glue, actually. Wait, where is the other end? Oh, there it is. I have PVA glue somewhere here. Oh, for fuck's sakes, chat. I can never find anything in the house. No? Okay. I put on the plastic glue. Break it even further. So this is the glue I use for 3D prints. If you're cheap like me, or just don't want to be wasteful, you can buy yourself a bit of plastic glue, and if you need to stick things together for your prints, you know, something didn't print right or there's an issue, you can use that then. It's nice, a nice way of... Place it down carefully and let it dry. Oh, perfect. So while that's drying, we're doing a 10 centimeter by 80 centimeter. I've changed my mind. It's not going to be a square. It's more than enough space. Way too big, I think. Yeah, maybe we'll do 8 by 8, to be honest. I prefer 8 by 8 centimeter. It's loads of space. And then the height is going to be really large. So the height is going to be 150. So the reason why we want a tall box design this time is because, yeah. Hi in City, welcome in. Hello, Wee. What is the number of your glasses? Do you mean like, what is my vision? I think it's -3.5 in one and -3 some 0.75. or it's -3 something in one and -3 something in the other. So legally blind in the sense that I'm not allowed to drive a car or anything like that. Oh, show. Oh! Undo, undo. We just want to make this a hole. Do you know what we're going to do? We're going to do a very interesting thing. Hi, Father Dougal. We're actually going to make the bottom thick. The idea behind this is that the ultrasonic sensor and the LCD display are going to be on top. Not big enough. Oh, Jesus. The LCD is almost 8 centimeters. Okay, okay, okay. We need to change the box. Anyways, where was I? The problem that's going to happen is that the box is going to be too, what's the word? Top heavy, because the LCD screen is going to be on the lid and the sonar is going to be on top as well. So all the electronic components are going to be on the top part. And so it's going to be too top heavy. So what we're going to do is we're going to add nice fill to the 3D print so that it doesn't get affected by that, basically. Now, we still don't need to make the walls too thick. So if we want a 2mm thick wall, this is 76, am I right in thinking that? 76 mils, and then this is 6. Okay. And then we just kind of lift it up a good bit higher in this case. Oh, and we lift it up. You raise me up. So it's a good few millimeters there. We can increase the fill if we want to as well. I got lost in the tragedy. It got lost in the tragedy, but also found. Oh, yeah, those balls would be really good. Wait, what do you mean it got lost in the tragedy, but also found a better picture? These are the ball-shaped Nerf gun ammo too. What's the tragedy though? Because you might say, well, tofu, why not instead of plastic use like a metal plate or something else in there? Oh, the ruler tragedy. I get it now. I get it now. I already forgot about the ruler. Yeah, no, I have. I'm waiting for the PVA glue to dry. Look at that. I haven't bought a new ruler in, how old am I? 8 years now because of this. And as soon as my ruler broke, I repaired it. Reduce. So we should add repair to it. Repair, reduce, reuse, recycle. There we go. Live by those words, even if the government works against you. I'm starting to sound like a conspiracy theorist. Yeah, this is good. And then we morph these. So even though the wall is 2mm thick, I've made the design so that whatchamacallit. Sorry, I'm just thinking. That actually first. I was also thinking about something else. I had a thought. Was it about the ruler, or the projectile, or about this? It's my train of thought. Oh, I need a hole as well, actually. So obviously this needs to be powered by the PC. And so the Nano has to be plugged in here somehow. I remember that now. Okay, so we're going to make the lid now. So this is the next part. We want the lid. Oh my goodness, that's not what I wanted. Because all I ever wanted. There we go. This is what I wanted. Zoom in here. A ruler is surely 3D printable. That is true. It could be. Yeah, I don't know. I wonder if there's like a... Because no ruler is perfect, right? It has percentage error associated with it. So I wonder how good rulers have to be, you know? Oh, not 116, 106. Whoops. So it's the same dimensions as the hole, basically, what we're doing. Click on that, and that would be 76 millimeters. We place it perfectly on top. I guess we want it quite well wedged, so we might make this a bit taller. Whoa! Sorry, a lot of thoughts are going through my head at the same time today. It's a very bad day to have a brain. Very bad day indeed. Actually, I've seen that kind of comment made on social media. Not a brain, but eyes. What a terrible day to have eyes. Or maybe it's not even social media. Maybe it's Twitch chat. I take it back. It's Twitch chat that says that to me sometimes. What a terrible day to have ears. What a terrible day to have eyes. That's just Twitch being mean to me. I forgot about that. Oh, that's the wrong button. It's this one I want, and that's 4 millimeters. We'll make it quite thick. So the other thing I want to do maybe is just on the side of this box to have a hole, quite literally, and it to be quite just a tiny thing, you know? Just so that we can have a ledge. So if it's 4 millimeters from the top, if we make it 5 millimeters in height, this hole. Why is it doing... Is that on an angle or something? Looks about right. Okay. I've said it many times. Okay, so really the origin is Tetsu being mean to me. And I've forgotten completely about it. I think we'll make it 6 millimeters. It's quite small, but 6 millimeters small. That's actually quite big. We will make that 4 millimeters. Oh, fuck. We'll morph that. Okay, so there we go. We have a little thing and you stick a screwdriver in. Yeah. Yeah. Might be even hopeful. Oh, wait, but you can do it without the ledge. Hold on. It can be even smaller. Chat, it can even be smaller than that because, yeah. It was over anyway. I think this is nice. A little in there so we can stick a screwdriver if we really need to. Tinkercad, only the greatest cloud CAD ever. What does cloud CAD mean? Like accessible directly on the internet? It is very good in terms of accessibility, I think. Hi, Corby. Welcome in. Not even 100. 315 stream streak. That is incredible. Okay. Now we grab our ruler. Let's see how our corner's doing. Okay, I'm not putting too much force, but it's not coming off. PLA glue. PLA glue, I'm telling you, lads. Let's grab the ultrasonic sensor here and let's measure it. I think I remember it being like 1 centimeter, 1 and a bit. There we go. Let's have a look. It is about 1.6. Was a tight fit at 1.6, I remember. We'll make a 1.7 in diameter. And what's interesting about that is that because the nozzle, yeah, maybe, maybe we'll do like 16.4 millimeters. There we go. That'll be interesting. .4. There we go. There we go. We lift this up. Nice. Gonna have 2 holes like this. Okay. We do want them as high up as possible in reality because the worse, or like the higher up we put it, the less chance it will interfere. But the problem is also the connection to the LCD screen. We don't want the wires over connecting. So we need at least 3 centimeters or so of space. So, oh, Jesus. So we might bring it down a bit. Maybe roughly around here. This looks good. Nice. Now, the distance between the 2 nozzles. Tanya, gotta ask, do you know what happened 40 years ago today? Chernobyl incident, right? If I'm not mistaken of the dates. Or is it close enough? It's not exactly that. The 1 centimeter exactly. Hi, Mord. Nope, it is 40 years exactly. Ah, okay. Today is the anniversary. 3.6, not great, not terrible. Hi, Patrick. I see you've watched it as well. I thought it was really good. TV series. I watched it like 3-4 times. I really enjoyed it. I know a lot of people seem to criticize it for its inaccuracies, but it is an artistic change and for easier digestible material. And so the little details and the little things that they excluded, in my understanding, were not terrible. I think a lot of people get very passionate about documentaries or like accuracy in something like a TV show like Chernobyl. That it doesn't translate well in a TV show if they did it. And it wasn't so far from the source material that it was a complete lie. Just like the order and structure of certain events. Like some events came a little bit earlier than others. It was very minor details, in my opinion. And like most things. How can I check the distance between these two guys? You know what I could do is I can create a 1 centimeter block and just do, like, physically make a ruler for myself. So 1 centimeter is 10 by 10 by 10. Since I know there's a ruler function, but it doesn't work properly for me. So this is a great way to help someone like me visualize this. Maybe from above. This would be easier from above. Let me click this guy here. Yeah, exactly, Zir. That's true. And it is a potential nose. That is true. Okay. The 1 centimeter block. I'm confused. No, that's definitely going in. So we'll do... There we go. Perfect. Perfect, perfect, perfect. All right, then we remove the nose. Maybe we'll just move it away. And then we morph these guys. All right. Not bad. Jump scare. Hi, Mord, by the way. I don't know if I said hello with the hexagon glasses comment. 30 stream streak. Holy smokes. I'm in a dilemma. Which one is worth it? To study CAD drawing or program? They're two different things, though. It just depends on what you need. Okay. The next thing we need to do is... we need to put the LCD screen in. Now, I have an interesting proposal, chat. What if I put the LCD screen not on the lid like in the original design, but behind? Since it's going to be tall, is there anything stopping me from putting the LCD screen here? I'm trying to think of the practicality for the students. I don't think there's anything stopping me from doing that. If I put it on the lid, the problem becomes very quickly that when we open the box, we could pull out wires unnecessarily when we pull up on the lid. I don't think there's anything stopping me from doing that. And I even thought about putting a little bench in there, like a little piece of wood for this LCD screen to sit into. Now the problem is that there's this little cutout on the right-hand side of the LCD screen. In the lower third as well. I was thinking about possibly putting it lower, but maybe to kind of allow the physics to kind of balance out a bit. Yeah, there's room here. There's room for this possibility. Okay, so the full LCD screen is 8 centimeters across, but the actual part that can pop out, the screen itself, is 7 centimeters? Height 7 centimeters. So we'll make it a little bit bigger, like 70.8. Lowering it might end up hindering readability, but moving it from the lid is a great idea. Yeah. So we kind of have like, there's pros and cons here for sure. Look, it's a prototype. We'll test it out, and if it's a... Yeah, look, it's in the name of feckin' science. Let's go. Let's go. So we don't care about the depth as much as we care about this part. So this will be... Wait. Did I do the nozzle size right there? Quick maths. Calculator. Divided by 0.4 nozzle. Yeah, no, it is divisible. It would be divisible because any 10 will always be divisible by point. Okay, because it's 100. Yeah, okay, that's fine. I just forgot what 100 divided by 4 is because I just moved it by 1 decimal place and I got confused. There we go. That might be even too generous. Do you know what? Feck it. We'll do it. Here we go. This will be... We'll do kind of in the middle. There you go. A medium solution. And we'll morph those. Now... Shit. I should probably get rid of this. The question is, how do we get the LCD screen to sit? Now, there are little holes on either side, but I got the dimensions wrong last time for that. But also, if it's wedged in, we could just have it sit, you know, on a little bridge. So let's see how we can do that. We make it 6 millimeters below. So we'll make a block again and we'll make it exactly 6 millimeters. So that would be 6, 6, 6. Block exactly like this. And we move it in here. Oh, shit. There we go. Can I look into the box, please? There we go. Thank you very much. Okay, this is very hard. Oh, what if we do it from the outside and we make it stick out? There we go. So let's pull this guy over here. Where'd you go? Come, what the? Bruh. are you... Why do you want to be over there? Okay, here we go. So, let's move this guy down. And right up to the... There we go. And then we bring it up. You raise me up. There we go. Woo! 666. Excellent. It's scary outside. I want to stay in the box. Speaking of, this is going to be a huge 3D printing project. When we finish the 3D print and we're printing it in the back, I didn't think about this, but we need to do some physics. So if chat has an idea of what they want to cover today, maybe projectile motion because of launching boxes, that might be fun. But yeah, if anyone has ideas. Do you know what I want to do maybe is pulleys. I want to do some videos on pulley systems. And it's been years since I did them. It would be nice to revise them, if at all possible. But I don't think pulleys are in first year physics. It might be difficult to find some problems on those. But if anyone has any counter suggestions, let me know. Otherwise, I think I'm going to do pulleys because I want to do a few YouTube videos on those. Okay, so then we basically get a block. And it's super skinny. Like 2 millimeters? Yeah, 2 millimeters by 2 millimeters by 80. Like this. So we're just gonna... how do I get it to turn? Not this way. This way. Hi, can I know the TW channel? What does TW stand for? Sorry. Hi, Citrix, welcome in. If you're anything like me, anortelism, when I do these projects, usually, I don't learn a goal, if that makes sense, but rather I have a project in mind and then I learn along the way what I need to learn, if that makes sense. So if you're anything like me and that's kind of the idea that you're involved in, maybe that's what needs to be done, if that makes sense. I don't know if that helps your situation at all. But if that's anything like what you need to do, that might be the solution for you. Now, I feel like this is the most inefficient thing I've ever done, but it's just to bypass my design and Tinkercad. Just Tinkercad things. Okay, 4 millimeters. I wonder how that's going to print though. Oh, how am I going to print this is a good question. How do we print the support? what if I print it on that wall? Okay, let me think about this. There's only a small thing to print here out of the air. And what if I make little triangles on either side? No, that's not going to work. Well, no, because all of this wall basically is in the air. Never mind, I take it back. I know how to fix the ledge anyway. The ledge, we can put a little triangle thing underneath it, like make a little bridge up to it, which is fine. Like a little, sorry. How, if you were to put up a shelf, for example, on the wall, you do the same idea. So, how would I? How about star shapes? Unfortunately, it won't fit then otherwise, but it is a good idea. That's actually generally a good idea. I know you're kind of joking, but making weird shapes helps with bridging. So in reality, what I would do is like circularize those windows so that it has a bridge to it. But it won't. This is a tight fit, so we can't do that. We're actually putting something in this case. Hi, Medjay. Welcome in. Welcome in. What we might do is we might 3D print it and put in some manual supports. I haven't done that in the Creality app yet, so we're going to check it out. We'll see how it goes. But regardless, I think we should fix this ledge though. What we can do is grab a triangle like this, okay? And so... that's not the right triangle. I need a... You know what I need? There we go. That's a wrong triangle. Unless I can make it custom? No. Yeah, no. This is right. This is right. So I want it like this. I want it that way. Tell me why ain't nothing but a dumb. Sorry. Don't mind me, chat. So we make the length. What was it? 80? Bruh. What are we Tinkercad doing? We're building a measurement, a speed of sound measurement device. Here's all the electronics. And I need to fit it into a custom box so that first year students can learn science. So a lot of the stuff we do is education stuff here, usually. She says having a demon core in the background of her stream. It was for educational purposes, though. It was. So this is what I was thinking about how to fix this ledge, basically. Oh my. A little window here. Go. Fucking weird, man. Oh. Oh, do you know what we need to do? We need to go from below. That. There we go. Oh. Okay. Looks good, I think. Okay. Okay, so we made a bridge anyway for that part. Oh, I hate printing tightly fitting bits. Never works out, but I also don't really know what I'm doing. +2 impatient for slow and steady. Luckily not printing anything needing to be exact. So I have like all of these ideas of what I want to do in the house. Someone uploaded some TikTok videos and it was all about doing mini projects in your house. Like improving your house little by little, but with like mini projects. And I thought, oh, that's a lovely idea because I'm quite a lazy person. By nature. And so I thought it's a nice idea of, oh, doing little things around your house to improve them. And so why not do it with 3D printing? So I'm hoping, I'm saying this optimistically, that I'll do that a little bit more this summer. But I just need to come up with ideas of how to improve my house. Like, it's a great idea, but like, what do I need to fix in my house? And there's loads of, like, my house is a state. We did buy it in not the best state, and that's fine. That's normal. But it's kind of like also, well, what do I need to fix? And I'm not very homesteady. Does that make sense? I'm not a homey person. That's wrong. I'm trying to think of a word. But yeah. I think I need inspiration and ideas more than anything. This looks good. Okay, I'm happy with what we've designed. Preliminarily. We're going to see if it works. Oh, shit. No, we need one more thing. So if the ultrasonic sensor is going to go there, the LCD screen is going to go there. And the plug naturally going to go that part. We need a hole. We need a hole for the power supply. And it's about, power socket, about 1 centimeter wide and about 1/2 centimeter thick. So we get a square. And it's about 10 in one dimension. And then 10. And the height would be less. We'll say 5. I got the axes wrong. Is it about 5? I want to make sure that it gets through comfortably, but doesn't pull the nano out as well. Actually, it's quite thick. Never mind. Just under, I would say instead of 5, it'll be 8. There we go. It's not even about being a traditional woman. You can be a traditional woman in the sense of like, well, if we were talking about traditional, like, what's the word? Yeah, no, traditional woman is a weird sentence, actually. It's historically inaccurate. What we'll say is, if you're talking about a nuclear family structure, there we go. What you need to be mindful about is that most housewives wouldn't have been able, it's not wouldn't have been able, it's another whole other skill, what I'm talking about, which is finding constructural issues and problems in the house and finding solutions for them. So it's not even about being a homebody. I have no designer instinct. Does that make sense? Oh, by the way, Citrix. I'm so sorry I got distracted. Dr. Tofu, there's a lab rat redeem. There is. Citrix, I'm so sorry. Are you still in the chat? Tofu rudely ignoring you. You are. Can you please tell me which lab rat pass you want, number one? And number two, let me know if you're okay with this, because some people didn't realize this, that I will be sending you these passages. I will be sending you these what are they called? Lab rat passes to your address. So only, obviously, just be wary that, you know, I would need your address. So only if you feel comfortable about it. But I'm so glad to hear that. We have a new lab rat pass coming soon. It's already out. I just need to print them before I make them available. So, Citrax. What lab rat pass would you like? Hi, Bloatware. Hello, Duck. Hello, Shadow, by the way. Wongfu, welcome in, welcome in. I love the glasses, by the way. Yeah, a few people said that it looks like the frames. So it's basically all the badges. There is in Discord, you can see a picture of it. In is it art? What's our channel called again? Where it's pinned. There we go. It's pinned in art. Thank you, thank you. And there's one more missing out of the pinned one, which is the Rad Rat. The Rad Rat is the only one that's left. Okay, I think I'm happy with this. I'm happy to test this at least. What's the worst that can happen, chat? Don't say anything. So what we're going to do is we're going to boot up Creality and we're going to see how the support works. I've never done support work. The bottom right. What is it? Can you describe it to me? What does the lab rat look like? Rat Senior. Perfect. Rat Senior. I have it down. Thank you so much. I'll hopefully be DMing you soon. If you oh, it's the oh, Harry, no. Okay, here we go. We have all the lab rat passes redeems happening. What's that one called? Is it called the lab rat? No, it's not. What do we actually call that lab rat? I know for the emote we call it Monka S, but is it intern? It's intern lab rat. That's what it is. It's intern lab rat. Yes. Perfect. I will send those as soon as I can. It has been known to take up to, I think 5 months was the longest one. I was about to say 6 months, but I don't think it was actually even 5 months, but still, it can take quite a long time. So let's play along with this Creality app and see how we get on with this. I don't know. I'm going to display it so you guys can maybe help me out to spot this. Creality print, here we go. So what we're looking for is, where are the supports in this? How do I... So, okay, let's go slice plate, for example. Mm-hmm. Yeah, we are making Mister. It took ages for the first... Yeah, to be fair, you were the longest one. You were the first person to redeem. So you got it the worst, to be fair, Harry. It just depends on the timing. Already saving, only 89 to go. The physics is the problem solving that makes me love it, but
it is possible to commit no
physics
mistakes.
Specifically, why I ended up loving it or choosing it was just a series of accidents. I wasn't crazy about There wasn't anything like, oh, this is what makes me want to pursue physics. It was a series of unfortunate events. And, yeah. I was very lucky in that case. This is because there's lab rats attached in secret security devices so we can escape the mines. A series of unfortunate... Yeah, it is. Like, I was a teacher at first. Did an applied physics course, master's. And I did well with my research group and they wanted me to stay on with a PhD. And they just happened to coincidentally get funding. And someone bailed on them last minute. And there was a whole bunch of... Like, it was really, truly an accident why I ended up the way I did. Story of my fucking life, but you know. Ah, there we go, support. Ah, oh, ew. Do you see the support on this? Nah. Can we do something else? We do tree support instead. I mean... It's better than nothing. Good afternoon. Hi, Kevin. Welcome in, everyone. I guess I've never seen this before, but now that I think about it, they never build a support from the bottom up. Oh, if this was a box, it would have been so much more efficient to flip this thing upside down. Hello from the humanities side of things. Welcome in, Rathaniel. Or Rathanel, even. Okay. I'd assemble the walls. The problem I have with that Wong Fu is that the point behind this is to make this really easy, user-friendly, and accessible to people who don't know how to 3D print and people who might not have the money and finance and the ability. So if I add, the more instructions I add to this, the worse this becomes. Does that make sense? Like, the whole idea behind this is I'm going to upload this all. I'm going to open a Patreon. There we go. This is my plan over the summer. And all my projects, my Demon Core, this, any of the educational stuff that I build, I'm uploading the electronic circuit, the 3D printing files, and all the programming for free and making it accessible. Because if I am not mistaken, correct me on this, you don't actually have to subscribe to Patreon. It can just be, like, nobody has to give me money. You can just... I know that some people have this thing of you can subscribe on Patreon and you can get access to stuff, but you're also allowed to give free stuff on it. Am I right in saying that? Can anyone confirm or deny the rumors I'm spreading? Because that's the plan I have at the moment. Perfect, Phoenix. Welcome in. So yeah, that's my plan over the summer, to set up a Patreon and give all of this stuff for free. Just for teachers and maybe even, you know, parents who are homeschooling or want to do more STEM with their kids. You know, just give it for free. Honestly, the 3D printing community is generally amazing. They build some of the most useful stuff around the house and everything. And their stuff is completely free. And they say, oh, just make sure to give me a thumbs up. That would be great support. Some of the community is pretty damn class. Okay. So what I'm going to do is I'm actually going to print using the yellow PLA. I was going to say I wasn't going to print at all. So the yellow PLA would be very similar to the PLA that we have at work. Because I might be cheap. And if we're going to print these, I might use the PLA at work. As in, like, send it to my workplace and say, look, I built this. Y'all spend your own money in building it. But I don't care if I have to. Yeah, we'll see. We'll see. So, yeah, we'll see how this goes. Please make sure there's nothing. Yeah, all good. Is the plate? All right. There we go. That's our first prototype. I don't have holes for the LCD screen. I'm hopeful that it sits in perfectly well in there, that it's really wedged in nice. It's ambitious hopefulness, but I'm hopeful nonetheless. I hope you're keeping well, Opinionat. This is a great moment to go for a P&T. Oh, did I finish this? This is really tasty bubble tea, but I hate the bubbles in this one. I don't like the chewy jelly bubbles. Well, maybe I do. I don't mind them that much, but not the ones in like cans. I like them fresh. But the milky, sugary drink part about this is the best part. Yeah. I prefer when you go to a bubble tea store that these things are fresh. But a tasty drink is a tasty drink. All right. Yeah, fresh is good. Exactly. They always give so much boba as well. It gets annoyingly sweet at one point. Yeah. It's great though. TFT is it has oh, I know the word. I don't know why I can't say it. So yeah, I'm gonna go pee. I'm gonna make myself a beverage, but that print is gonna take forever, lads. I think it's like 2 hours, surely. Let me see. 4-hour print! Yeah, okay, we might as well get comfortable. So that being said, what we're going to do is we'll definitely see it by the end of stream. It is Sunday after all. I'm gonna pee. I might explore a classical general physics, excuse me for burping, textbook. And we might do a physics lesson, because it's only been an hour since I've been streaming and I went straight head down into the project. But yeah, we'll do some physics lessons today before we play some games. Gaming including Elite Dangerous and Extinction Day. Elite Dangerous is going to be interesting, I think. We bought enough money now to kit out our new spaceship. I'm looking forward to that. Yes. Yes. All right. I'll see you in a bit, everybody. TNP. We'll be back. Difference was 1.37 meters, 1 Gimli, but remember it has to be a negative. And also remember that when substituting for gravity, you have to make it minus 9.81 meters per second squared, because gravity is acting against us. We then get ourselves into a quadratic equation and we use the minus b formula. We know what the a component, b component, and c component is. I simplified the mathematics here and subbed in all the values, but we get 2 possible answers because there's a plus or a minus part of the equation. 2 answers result in 1.124 and the other one is minus 3.189. And I am ignoring the negative sign because, well, time doesn't move negatively, technically. That's another story for another time, why it can be negative. But in this case, we can only take a positive answer for time, and so we've determined that Gimli has been in the air for 1.124 seconds. Now that we know the time that Gimli has spent in the y-axis, how long he was going up and how long he was going down, that's also the amount of time that he spent going in the x direction. That kind of didn't change. If we know how long he was up in the air for, we know exactly that's how long he was going for when he was going in the x direction with no air resistance, and it didn't change in speed. And so using your simple speed equation, v is equal to distance divided by time, we know that his speed was 2.83 in the x direction. We know he was in the air for 1.2 seconds. Multiply those values together and we estimated that he got tossed at 3.18 meters. You can evaluate the video and determine that maybe we're slightly off on the meters. Feel like there could have been an extra meter there by eyeballing the image of the film. But overall, I thought the estimations were pretty accurate. I hope you found this video informative, educational, or at the very least, a bit of fun. The most extended credits go to Medjay, a dear friend of mine who animated this whole series. Fantastic artist and a fantastic human being. And thank you so much finally to my Twitch chat who participated live in solving this problem. Take care of yourselves, stay safe, and stay curious. Imagine the year is 1943 and you live in the Soviet Union. You and your family had to pack up your belongings and move across countries to Kazakhstan for your safety because of World War II. You abandon your home, your life, your work, your career, your friends into a very, very crammy train, into a very crammy apartment that you share with many others because you know everything is just up in flames. The whole world is at risk at the moment. However, one evening you get a phone call. A very important man is on the other line and he says, you are to return to Moscow urgently. You have to carry out specialized work. And the phone hangs up. The weight of the nation is on your shoulders, but you must answer that call. You must leave your family again and travel across the country back to Moscow so that you can work on the atomic bomb. This is a story of a scientist on the other side of the wall. Her name was Zinaida Ershova, and please give me this opportunity to share her incredible story. She was born on October 23rd, 1904. She enrolled in Moscow State University and was part of the Faculty of Physics and Mathematics. She found somewhat of a calling in laboratory work, in experimental work, and so worked in the chemical labs. She absolutely loved working with radioactive materials. I only laugh a little bit because that's a scary area to love to work in. But she connected her life through it, and so she worked really hard in working in a radiochemical laboratory. In 1924, she was going to meet a man that was going to pave her way into her work and field and area of expertise. She met Vitaly Chlopin. He was the deputy director of the Radium Institute, and they had almost a lifelong mentorship. Vitaly basically guided Zinaida in her career, in her science, in her research, and helped her get the opportunities that she did. She started working in the Moscow plant for rare elements. This was the main source in the industrial production of radium at the time. She became head of the physical laboratory very quickly, basically being one of the main credited contributors to the launch of the radium production at the time in 1931. Like many scientists around the world to this day, they need to explore and travel around the world and get an education outside of their own country. And so in 1936, Zinaida traveled to Paris. She had a scientific internship in the Radium Institute. She worked under Irene Joliot Curie. This is the eldest daughter of Pierre and Marie Curie. While she was there, she did some amazing individual work and published a vital paper of the 238 and the 235 uranium ratio. This was in 1937. She defended her PhD in 1943 and successfully received her doctorate for that research. The pact is broken between Stalin and Hitler, and so we are in the middle of World War II. In 1943, Ershova was evacuated to Kazakhstan along with her family and friends, but of course, going back to the initial part of the story, she gets a call back, and she is sent back to Moscow. Under Chlopin's recommendation, she was working in Geretmet. Kurchatov's institute was a famous institute in Russia at the time, and so it was the focal point of nuclear research. Zinaida played a crucial part in this laboratory. She was the driving force behind obtaining uranium carbide and uranium metal. She was also one of the founders of the Institute of Special Materials. This later became NII-9. She was also appointed as the first head of the radiochemical laboratory there in 1946. She was the leading force and the researcher behind a lot of the new methods at the time of basically obtaining materials for radioactive development, both for bombs and for nuclear research. She was the one who produced the plutonium for the first Soviet bomb. She was a pioneer in the research of polonium at the time and awarded the Chlopin Prize in 1968 for her work in the chemistry and physics laboratories. If it weren't for her research in these areas, who knows if the Soviet Union would have pushed as far as they did with nuclear research. Because despite the fact that the Americans did make the first nuclear bomb, the Soviet Union did obtain the template and were able to make their own nuclear bombs at the time. The material obtained to be able to do so were obtained with aid and with the driving force behind Zinaida Ershova. She was awarded many Stalin Prizes. She got the Stalin Prize in 1949, 1951, and in 1954 for her contributions to the USSR nuclear research at the time. She left her research facility in 1989 with over 40 years of dedicated service. She passed away on April 25th, 1995. She's remembered to this day as a prominent scientist in Russia, and she is often referred to as the Russian Madame Curie, and sometimes... Hiya! Welcome back, everyone! Guess who's back? Back again. Tofu's back. Tell our friends. So, I have two biscuits, two cheeky biscuits with my cup of tea. It's the knockoff Jammy Dodgers. It's the leftovers. I have no more left. I got it all over me. All right. We'll eat our Jammy Dodgers. And we will now discuss not sure where the question is. Last stage. Welcome in. On bourbon. Love bourbon biscuits. They're very goodies, but. Good American morning. Is it a good American morning? I hear there's some stuff happening in America that's not so good. Wait, did Trump get assassinated again? Or sorry, and I heard something very briefly on the news. Was that did that happen? Or am I crazy? Was that on the news today? I could be crazy. Because I saw a clip, a meme from Mulan, where Mulan misses a rocket, and you know the dragon is giving out. It's like, how did you miss? He was 3 feet in front of you. And some comments about another assassin, but I didn't see anything. This is how I get my news. I get it on TikTok. Something went down, but everyone's okay. Oh, okay. Anyways, that was my news today, TikTok. Seeing a clip from Mulan about it. To be fair, rock out. That's a good way to live these days. This is good tea. Sometimes you get your brewing just right. Okay. So there wasn't a proper shooting or anything. Okay. That's a great emote. What the feck? That's a really nice global emote. Medjay. Ah, good tea. Good tea. Yeah, I do like this mug as well. We have obviously our own merch mug, but this is my non-merch mug. Nathan got it to me. I think he got it on Etsy. I like the idea of supporting artists on Etsy, but anytime I've been on it, I don't know if any of you guys are running into this issue. It's fucking AI. That and Pinterest, I was just getting into it, and it's just all AI images and AI generated shit. Is anyone else finding that issue at the moment? It's so hard to find real artists on them. But maybe that's my, that's maybe my narrow issue. I have a lot to say about that news, but I'll hold my tongue. Fair enough, Neela. Okay. I was just saying it, actually. Like, I couldn't believe just how much, on the news we've heard, seen it. You can select to hate all AI images on Pinterest. Can you, though? But I think, if I'm not mistaken, the problem is that people are not declaring that it's AI. Oh, is that a new... No, I know what you're on about, Medjay, now. Yeah, sorry. I've heard about so many artists being flagged as AI now. You're right. If it's cheap enough, it's probably AI and the mass production one. Yes, Jay, you're right. It's a new thing. Yours truly, Leon. Thank you so much for the 2 months. Really appreciate it. Sorry, I just love your username. We should play Resident Evil 9. Yeah. But I actually get really... I need to... Does anyone know how to turn off the AI setting in Google? Because it's pissing me off. Is there a way to do it? So do you know when you search in Google and the first thing pops up? And not just Google, Bing, everything, right? The first thing is an AI answer. I'm getting really frustrated personally in science because it gets it wrong so many times. Another thing that drives me up the wall is if someone is arguing against me. about something and they use it to make their point. You can I've tried that. It didn't work for me. Okay. I might look into it. Yeah. Again, yours truly, Leon. Thank you so much for the resub. Really appreciate it. That username is so good. RE9 is so good. I'm sorry. I'm sorry. Loads of people were playing Pragmata earlier, but yeah, I haven't played it. It does seem like a lovely game. Anyways. Yeah, no, AI can be very, very wrong sometimes, unfortunately. Especially, yeah, so many things. And it pisses me off. So back in my day, I used to be pissed off at trolls. Now it's the AI I'm just getting pissed off at all the time. Let me grab a book. Okay, chat. We have two options of learning physics today. We have physics, some topic in physics, or proper hardcore electronics. So, do we want to do something in physics or something in electronics? We'll do a very, very simple, quick poll. Now, physics could be anything. It could be electromagnetism, it could be mechanics, but what realm are we feeling today? And it's not even electronics we're really studying. It's specifically like electric circuits, so AC, DC. So here we go. I'll put a 3-minute vote. It's just a really, really quick one. Let me know what's the vibe today in the chat is the question. I choose that light reading in physics. Yeah, I mean, they're both pretty light. Look at that. I am looking forward to reading a lot more this summer. I've already gotten into... Oh shit, I need to close my PLA glue. I've gotten into a good habit of reading a bit more, which is great. Like anytime I'm sitting down, not to doom scroll, have my book ready. And I'm getting addicted to the book. I'm only like 1/3 into it. It's only like 200 pages in. Secret History by Donna Tartt or something. It's so... I love the writing in it. Even though, like, for the first 150 pages, as most books, nothing really happens. I was really happy with just, like, I don't know. You're interested in the characters. There were so many books when I was younger, I was like, ugh, I'm not interested in the characters at all. For physics. Oh, have you read it, Python Snake? Yeah, it's very lovely. I don't know what the story is about. I haven't gotten into the story yet. I'm just fascinated by the characters and just fascinated by the chain of events in the stories. It's great so far. I highly recommend it already, and I'm only like less than 1/3 in already. I think it's a big book, but it's quite interesting. But yeah, I have it with me on the go. I'm a bit pissed off that the chapters are so big because I like to do chapter assignments sometimes for myself. Like, okay, I'm going to read a chapter before bed, but her chapters are like 80 pages long sometimes. So it's like, I don't know. I need to go to work tomorrow. So you just need to break it up for yourself a little bit. But the book I read before that had way too many chapter breakdowns. I'm trying to remember who it was. Was it Jules? No, Jules Verne I read at the beginning of the year. Oh, it was Troy by Stephen Fry. He had a huge breakdown in the chapters. That was, yeah. Yeah, exactly. Shorter chapters make you feel like you're progressing faster. Yeah, yeah. Thank you, Chill. Welcome in, welcome in. We're just voting on what we want to study. Do we want to study physics or do we want to study electric circuits? It seems like the vote is leaning towards physics by a substantial amount, which is, you know, it is what it is. We don't even know exactly what in physics we're studying. It's just, let's abandon circuits for now. And let's go into physics. So, let me see some chapters and see if there's anything interesting here that catches my eye. I'm going to try and pick topics that I don't know anything about. So, well, obviously I know something about them, but, you know, because I teach a curriculum, certain parts are left out of the curriculum. So I'd be interested in learning or referencing a textbook and teaching a few things occasionally from them. Ooh, okay. Linear momentum and collisions. So, something that I never studied, I think, I could be wrong about that, is... No, I did, never mind. I got excited there for a second. No, I studied all of this. We could do rotational dynamics. That's kind of scary. We could do fluids. We could start with like density and specific gravity, then go into pressure and fluids, atmospheric pressure, Pascal's principle, buoyancy, Archimedes' principle, then maybe get to Bernoulli's equation. Collisions should not be studied when you're driving a car or a passenger. Maybe there's a fun particle physics one. Let's see if there's anything fun particle physics-y. There is special theory of relativity. I haven't covered that in ages. There's even special theory. Yeah, I'm surprised how much special theory of relativity there is. There's Galilean and Newtonian relativity, the Michelson-Morley experiment, postulates of relativity, simultaneity, time dilation and the twin paradox, length contraction, four-dimensional space-time, Galilean and Lorentz transformations, relativistic momentum and mass, the ultimate speed, energy is equal to mass. I think if I remember this book, though, that I don't like, is that it doesn't actually teach you proper equations. This is so introductory because it's a first year physics book. It's so fluffy. It's all text. And it's kind of like, listen, I like a little bit of light-time reading, but we're physicists. We want equations, you know? So if I remember correctly, there's not much or at all any equations. Oh, it's all text heavy. Oh, yeah. The time dilation has an equation at least. Must run the calculus. When will we cheat physics and go faster than the speed of light? Well, you can go faster than the speed of light, depending on the perspective. Isn't that the whole story? That from an observer's perspective, you could be going faster than the speed of light sometimes. Okay. Here we go, chat. I am feeling fluids. Newton and gravity. or linear momentum. There we go. Those are the 3 topics I'm feeling today. So, a new poll. What topic to teach? Newton and gravity. And when I say Newton and gravity, we're assuming the 3 laws of Newton's 3 laws are already covered. And even some circular motion. So we're going straight into Newton's law of gravity, gravity near Earth's surface, satellite, weightlessness, Kepler's law, gravitational fields. Like, we're studying proper gravity for this. Newton gravity. Linear momentum and collisions. Oh, I can't fit that in, but linear momentum and collisions. And or fluids. So we'll set the vote for 5 minutes. Vote away what you feel like doing. Time is a very interesting existential topic. It is, yeah. A lot of people think about it a lot. I don't know if I think about it much anymore. I used to. Hasn't come up in my brain very often these days.3D print is underway anyway. So yeah, if we're doing Newton's gravity, we're doing like weightlessness, satellite orbits, things like that. If we're doing fluids, we're going to do pressure in fluids, atmospheric pressure, gauge, Pascal's principle, buoyancy, and Archimedes' principle. I haven't done buoyancy in eons, a decade, I would say. So I would be looking forward to that. And then momentum would be things like momentum, conservation of momentum, impulse, elastic and inelastic collisions. And we'll see how far we get. We might get to the center of mass topic, but doubtful. Just because that's a lot to cover. I'm very rude looking at my phone. I apologize. I don't like looking at my phone during stream. I always feel like I'm looking at my phone during work hours. I know it's not the same thing, but it feels like it sometimes. My sisters are messaging me. Oh, okay. They want to cancel meeting. Meeting cancelled, nice. No, meeting with my sisters. Yeah, my sister's coming back to Germany, and yeah, she just messaged saying she's probably going to be tired on the day, so doesn't want to go out. 69% on fluid. Stop the count! Yeah, I thought it meant... it's I understand. Oh, my nose is itchy. I hope I get my money back for my train, but I might not be able to. It's annoying. Oh man, my nose is so itchy. I feel like sneezing. Ugh. Ugh. Sorry, 2 seconds. Train. Oh, do you know what's on my wish list? Sims Legacy, and it's on sale. I'm really tempted to buy it, even if it's just on credit card. I've never played the original Sims. Have you guys played the original Sims? Click here to cancel your booking. Here we go. Ichi knows means you're going to fight. I thought it was cancel. Cancel entire booking. Confirm and get refunded. Yes. Oh, let's go! I actually can get refunded for this. Wait, the ticket's like €30. The Sims Legacy might chat. I might be able to afford the OG Sims. Also, fluids win. We're going to do fluids physics, but also 2 seconds. My sister's cancelling on me might have given me enough money to buy the Sims Legacy. I'm very hopeful now. Glass half full, lads. Glass half full. Let me look at this. Wish list. I think it's at the bottom. Sims Legacy. It's €11.99. It's a 40% sale. Ah, come on, lads. That's a steal. Let's be honest. That's a steal. I should buy it. I shouldn't even question it. 40% is loads. Chat, stop talking me into it. Stop talking me into this. You guys are such an awful influence. Thank you, Moffarmer, with 100 biddies. Really appreciate it. Stop. Like, I'm not made out of money, you know? Oh, Sims 2 Legacy. I played The Sims 2 when I was younger as well. Oh my god. Why is that added to my shopping cart? Oh, days. Oh my goodness. Oh, yeah. Continue to payment. Purchase. Look away, chat. Look away. Chat, look away. Thank you for your purchase. Oh, she did it. Yeah. So the minute I got money in my account for like 30 seconds, I spent it immediately. I have no self-restraint. Absolutely zero of it. Money in an account in this... I know! It was there for 30 seconds, Stav. There for 30 seconds. Yeah, no, I'm actually glad I bought those tickets. I spent a little bit extra money to buy premium tickets. Just because you can refund them. I don't know, I guess I had a feeling that I would need to. You should spend it on buying me stuff instead. Okay, so the vote has come in, and we are going to learn some fluid physics. So, I wonder, can I do some demos for you today? On the spot, in the moment. Yeah. So I'm going to use this textbook to reference, like, what will I teach? What's the next topic? And obviously make sure I get the right equations. But I hope that it's all just correct, just generally correct anyway. As in, like, I'm going to spout things that I know about already, and I hope I get it right, because it's been a good few years. I teach some of this already, so I have good foundation. But I'm going to try and teach or go into stuff that I haven't always covered. Alright, here we go. Fluids. Look at the rocket shake. Oh yeah, my rocket shakes because of the 3D printer. It's not ideal that my 3D printer's on that table, but because the CFS light is on the left-hand side, the CNC cannot be moved because the CNC is really, really heavy. Basically, yeah, I need a new table. Yeah. Okay. A massive long desk. It's not just long, I need a thick desk. Not thick. What's the word? Well, actually, no, I do need thick because it has machinery on it. Wide? Yeah, wide desk. I need a big, big, wide desk. I have a desk. I know I have a desk. And I want to get it. But it's on my mom's house. So I need to get a car first, which I need to get a driving license for, which I'm sitting in 2 weeks' time. Here we go. So I'll show you what's on my whiteboard. It's kind of incoherent at the moment because it's a little bit of everything for a theorem. Ta-da! So it's from the maximum power transfer theorem. Have I uploaded that yet? I don't think I've uploaded this yet. It's coming out soon. In cinemas near you. Yeah, that's coming out pretty soon. But I recorded the DC version and I want to also record this week the AC version. So I want DC and AC coming out roughly at the same time so that people have access to everything and anything immediately. Thunderstruck. Yeah, 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 thunderstruck. So just going to clean the whiteboard first before we start our lesson. And then after this, we will go on a break for a little while. I'll get some liquid courage to play through Elite Dangerous. I'm looking forward to it, actually. I might be nervous about the combat, but I'm looking forward to trying combat in Elite Dangerous. Might be a lot of fun. Let's see. Ugh. Go. There we go. All right. We let that dry out a bit. So, what we're going to do is we're going to cover introduction to fluids. I was going to say fluid dynamics, but dynamics means specifically moving bodies of, well, fluids. But we don't need to actually cover moving bodies. We can just cover general fluids or general introduction to that kind of realm. But before we actually can get started on those kind of topics, we do need to talk about some concepts and ideas that you might feel like isn't anything to do with fluids, but it is very important. And one of those things that we need to cover is density. So, lab rats and labradoodles, what is density? The $1 million question. It's kind of a weird one, and it might seem like something that you studied really, really early on. But I wonder, how long did it take for all of you, if you can self-reflect a little bit, to get a instinctual understanding for density? Yeah, it's mass over volume ultimately is the unit for it. But you're kind of right in thinking about that. It's the amount of stuff that you have compacted per unit volume. So let's say I have this container and we're going to determine the density of different things. I will put water in here. We're going to weigh it. And I will put in liquid mercury in there and we're going to weigh it. And I will put in alcohol into it and we will weigh it. And because we have the exact same amount of volume, their weights are going to be different and we can determine which stuff is more dense than others. How much stuff we've compacted anything. So, for example, let's take the idea of feathers. If you zoom in to what a feather looks like at an atomic level, you have a container and you have atoms in it. Now, if you zoom in, let's say, I'm just reading chat there, into lead, for example. If we zoom in onto lead, for example, what you're going to find is that there's a lot more atoms in lead. It is a lot more dense than a feather is.
Commander,
even though you have the exact same
course.
amount.
There's coffee in that nebula.
Even though you have the exact same amount, the amount of atoms in lead, the element that we're looking at, is way, way, way more than in feathers. Now, that's kind of a bit more extinctual understanding, but we do have an equation associated with density. Density is equal to mass over volume. The SI unit for mass is kilogram. The SI unit for volume is meters cubed. And so that is the SI unit for density, kilograms per meter cubed. And the symbol for density is rho. Rho is a Greek letter. It's not just a backwards P, it is a different letter, so make sure it's not just a P that you write. And drunk looking P is what I usually tell my students. And that is the universal symbol for density. Let me check how dense my coffee is. We could do scientific experiments on the density of coffee. It's very, very doable for sure. We could definitely do it. What we need is, there's a proper name for it, but I call it a density bottle. We'd need a density bottle to be able to do that kind of science. Oh, my mouse doesn't work on platform. Damn. I'm pretty dense until I've had coffee. You know what? The feeling is mutual. Not that I think you're dense, I just mean, yeah, okay. Anyways. So let's solve a mathematical problem. I'm going to give you guys a mathematical problem and give you an opportunity to solve it for yourselves. I'm just using one from the textbook. What is the mass of a solid iron ball? It's not just steel, it's pure iron. A solid iron ball with radius of 18 centimeters. What is the mass? So I'm not asking you to calculate the density of iron. Maybe you can go and check that out. But instead, I'm actually asking you what's the mass. So you are allowed to Google something. I give you all permission to Google the density of iron. Just watch out for the unit. Hi Razor Gem, welcome in. You had to say it Oscuelga. On will gum, dulga the unlehers, mushte the holly. And only then can you go to the bathroom. Otherwise, sit your butt down and pay attention to lecture. Steam is so lovely. Thank you for your purchase, they say. Instead of, oh, how dare you spend it. I can say by that number that you're off, Neela, by 1,000. Remember I said watch out for the unit. If your number is right, it's not 7.87, it's 7,870 kilogram per meter cubed. We're going to keep it in SI. Chances are what you got is 7.87 grams per centimeter cubed, which is more often used in chemistry. But in physics, we tend to use kilogram per meter cubed. So watch out always for the unit when you're Googling things. But it's okay. We got your answer and we just multiplied it by 1,000. Oh no, don't cry. You almost had it exact. But do watch out for the units. Units are always going to be difficult to deal with. So the mass is... oh yeah, we want to rearrange the equation. If we're looking for mass, that's density times volume. So we have the density, but do we have... Sorry, I need to learn how to use this marker. Do we have the volume? We don't. But we were given the radius. So what is the volume of a sphere? Volume is equal to 4 over 3 pi r cubed, I think. Someone should check that just in case. So the volume is equal to 4/3 pi r cubed. Remember the density of the deal there for a second. Welcome in, Kenny. So volume is equal to 4/3. Pi is just a number. And then we're going to sub in for radius. But be careful. You want to put it in meters because we're keeping everything in the same units. So it'd be 0.18 to be cubed. Also, is that the radius or the diameter? It is the radius. Okay. 0.18 to be cubed. Oh, I do have a calculator. Hey, Phantom! You call that a mine? A mine? Shameful. Shameful. We get the volume to be 0.0244 meters cubed. I had to double check it. You might say, oh, that's tiny, but not really if you think about it. 1 meter cubed, just 1 freaking meter cubed, is a meter stick by a meter stick by a meter stick. That's a huge amount of volume. When does it upgrade to very old friends? 24 months, so 2 years, Phantom. But you've been here a lot longer than that, but it's subscription specifically for the 24 months. Teachers seem to love the radius centimeter conversion so much. As a student, I am not so sure. You are getting close, very, very close indeed. So, density is equal to mass. Oh, sorry. Density multiplied by volume is equal to the mass. And because we have all our units in the same, well, SI units, we're going to get our answer for the mass in kilograms immediately. The density was, what was it again, Neela? 7, 8 something? What was the density of iron, chat? Seven, 8, 7. 0. Multiply by 0.0244 meters cubed. Would you look at that? Our units cancel out, which we know that we did this correctly. So the meters cubed and the meters cubed cancel. We're going to be left with kilograms, which is the SI unit for mass. So then we write it out. 7870 multiply by 0.0244 192.028 kilograms. Ooh. Sorry. 28. Whoa, that is heavy. So if I had a ball of 18 centimeter diameter, so a ball about this size of steel, it would weigh 192 kilograms, which makes sense because its density is massive, 7,870. It has a massive density for sure. So that makes sense that a steel ball about this size would be absolutely unliftable. Lurk away, not the brain. Welcome in, welcome in. So the textbook, I don't actually know what the textbook said. It says 190. Oh, I did some crazy rounding. So there we go. Now, another type of gravity I want to cover is the notion of specific gravity. Oh, sorry, density is specific gravity. This is the one that I'm thinking of. Yes. So this is when we compare the density of an object to water. So let's say we get the steel one, right? So someone mentioned the steel one earlier. So 7,870 kilogram per meter cubed. Now water at 4 degrees, the standard pure water at 4 degrees roughly, is about 1,000 kilograms per meter cubed. So the specific gravity of water, of steel, of iron, god damn it. The specific gravity of iron in this case would be 787. That would be the specific gravity. The question then, I suppose, is, well, what's the unit for specific gravity? Not necessarily phantom. You could be dense and just have a very large density. It could have nothing to do with specific gravity. What's the unit in this case, chat? Sorry, the light is kind of glaring. There we go. Ta-da. Unitless, exactly. The units cancel out, it's a unitless parameter. So the specific gravity of a substance is unitless, and basically when you say that number to someone, oh, it's 7.87, you can kind of think about it that it's 7.87 times more dense than water. So looking at that, you know immediately, it's going to sink in water. But then if you take wood, and wood could be anywhere between 400 and 600, and it depends on the type of wood, how it's treated, all those things. But I'll say roughly some wood can be about 600 kilograms per meter cubed. Its specific gravity then is 0.6. Because the number is less than 1, reading that immediately, you know, it's going to float in water. So it's a really good measurement of roughly knowing the density of objects, even for people like me and you. Well, yeah, no, we'll say that. That number means something to us immediately. When we think about something being dense or not dense, we usually think about, floating or not floating in water. So when you talk about specific gravity, if it is less than 1, it's going to float. If it's more than 1, it's going to sink. But then what does it mean to have 1? It means it has the exact same density as water. They're both equal. Sit down for a moment here. It becomes water. So that is density and specific gravity. With that topic covered, hi Spin, welcome in. With that topic covered, we are going to start covering pressure in fluids. So this is where actual fluid dynamics starts operating. We're going to do a bit of maybe diving physics and so on and so forth. But for now, let me clean up the whiteboard and we'll take a small break because I don't know why I can never stand on my feet for so long. I lecture for hours easily, but Twitch, you guys wipe me out. Make me very tired. Where's my spray bottle? Has anyone seen the spray bottle I spray my lab rats with? Is helium more dense than hydrogen? I don't know. I genuinely don't know. You'd have to Google it. Because if you get pure helium, pure hydrogen, it also depends on the type of bonds they create and what they are like. And which isotopes you get as well. The isotope part is important too. Okay. Nice clean board. And hydrogen is 0.009. It depends what it's like in its form, because isotopes exist as well. And if you put it with itself, does it create a bond? You know, for example, if you say, oh, pure oxygen, do we assume that it's an O2? Do we assume that it's an ozone layer of O3? It'll be interesting to see those kind of things. And obviously which isotope it is. Because, for example, let's take something like hydrogen. Hydrogen can exist as hydrogen, just one proton. It can exist as one proton and one neutron. It can exist as one proton and two neutrons. And it can exist as one proton and three neutrons. So it already has the mass almost of a helium atom already immediately with that isotope. So it does depend on those kind of little things. So the next topic we're going to cover is pressure in fluids. I want you to think long and hard what the unit of pressure is while we go on a little ad break. I'll be back in a little while. Gravity can mean Einstein's gravity theory. It could mean Newtonian's gravity theory. It could mean weight. Or it can mean the G value, the 9.81 meters per second squared that is on the surface of the Earth. Which one is gravity? All of them. It just depends how you fill in the sentence. Generally speaking, gravity is referred to the force of gravity. In classical physics, we refer to this as Newton's law of gravity. F is equal to G times mass 1 times mass 2 all over the distance squared. Sometimes loosely, we refer to gravity as the acceleration due to gravity. We usually note it as a lowercase g. And that is 9.81 meters per second squared on the surface of the Earth. That means if I drop anything, I always look for something to throw or drop in my lectures, I swear. If I drop this rock with a really cool fossil, it means that every second its speed increases by 9.81 meters per second. Hence the unit meters per second, or meters per second squared. The acceleration due to gravity is due to the force of gravity. It is not referred to as gravity itself. Sometimes, however, loosely in the English language, we might refer to that as gravity. Hence the confusion. One is the force of gravity, F is equal to ma, or F is equal to G times m1 times m2 squared. And the other one is just lowercase g, the acceleration due to gravity. Make sure we know the difference between these two. All right, now that we have all the basics, let's get off the surface of this planet. Here is a very accurate representation of planet Earth. And this right here is you. Not drawn to scale. R represents the radius of Earth, and X is some distance off the surface of the Earth where we would like to get away. This is the kinetic energy of U, the mass, that is required to get off the surface of the Earth with the escape velocity VE. Let's start with Newton's force of gravity. G is a gravitational constant. It's just a universal constant that we need to use to adjust our numbers. Lowercase m is your mass. Capital M is the mass of the Earth, and X is the distance between you and Earth. So, what do we need to do? We need to put work into getting off the surface of the Earth. The equation for work is force times distance. Now, we're doing a little thing here where we have dw dx. Sub in the value for F from the above equation. This is our final expression. Our limits for integration are going to be from R to infinity. Because we're starting from the surface of the Earth and we're trying to get as far away possible. What's the furthest thing possible away? Infinity. Now, what does this integration really mean? Well, we have a bit of a problem. The work required to get off the surface of the Earth isn't just a constant value. It actually changes depending on how far away from Earth we are. Because the gravitational pull of the Earth is changing because we're increasing the distance between us and Earth. So each time we get further and further away, the work required takes less and less. And that's exactly what integration really does. We're taking tiny, tiny increments of the distance, calculating the work required, and adding them all up together between R and infinity. I won't get through the calculus of this. If you need a little bit of help here, I advise going through Introductionary to Calculus and Integration. So we ultimately get minus gravitational constant times the mass of the Earth times the mass of u all over 1 over x, where x has the limits of infinity to r. That becomes 1 over infinity minus 1 over r. 1 minus infinity, what the heck is that? Well, think about it. Infinite means super, super, super big. Flip it the inverse. 1 over a huge number. It's so big that we pretty much approximate it to 0. Hence, this becomes 0. I hope I have not offended too many mathematicians here. Inside our bracket, we're just left with minus 1 over r. The two minuses will cancel. And so we get the gravitational constant mass of the Earth, the mass of u, all over the radius of Earth. All right, we need to put that amount of work into getting us off the surface of the Earth. Well, we're going to transfer it all as kinetic energy. The way to get off Earth is by putting energy into our movement. Half mv squared. Let's equate those two guys together. The two m's cancel, your mass. Rearrange the equation to find the escape velocity to be equal 2 times gravitational constant times the mass of the Earth all over the radius. This is a pretty good equation. We can sub in values already if we wish, but we can get it down simpler. When we're on the surface of the Earth, we have a force of gravity that we're experiencing. Weight is equal to mg. And we can equate it to Newton's gravitational force. The two m's cancel. We can rearrange the equation to find the acceleration due to gravity is equal to the gravitational constant, the mass of the Earth, divided by the radius squared. If we move one of the r's up here, this looks familiar. We have that exact relationship here, and we could sub it in. Ta-da! We have the escape velocity. The escape velocity is equal to root 2 rg. We know what the radius of Earth is. We know what the acceleration due to gravity is on Earth. Sub in our values, we get that the escape velocity is 11.2 kilometers per second, or 11,200 meters per second. I'm so sorry I don't know imperial, so I'm not even going to mention it. So the conclusion of the video is really, really cool. It means that to overcome the gravitational force of Earth, you need to yeet yourself off the surface of the Earth at 11.2 kilometers per second. That's really, really fast. But what's really cool is that it is mass independent. It means that it doesn't matter how much you weigh, whether it would be just yourself or a spaceship or anything like that, you all have to reach 11.2 kilometers per second. Just to highlight a misconception here, it doesn't mean that it doesn't require more force to get a bigger object off the surface of the Earth. For example, a really, really heavy spaceship is going to require more force. F is equal to ma. That m is going to affect the force required to launch your big spaceship versus a small spaceship. But the velocity that it needs to achieve remains constant. I hope you enjoyed this video, and I wish you luck in getting off the surface of the Earth. It's a scary world we live in these days. I'm holding something really special in my hand. This guy is an inductor. Earlier, I made a series on the capacitor, and the equivalent opposite of a capacitor is an inductor. A capacitor stores energy in an electric field, while an inductor stores it in a magnetic field, i.e. electromagnetism. The principle of an inductor is very different to a capacitor, however. It is a copper wire, or any conducting wire to be fair, wrapped around a medium, such as this wire wrapped around this marker, so that when a current is going through this wire, a magnetic field is created. Hopefully we know that when there is current going through a wire, an electromagnetic field is generally created around one. But this is a unique case where the wire is being wrapped around a coil. The current is very important in this relationship. As the current changes, so does the electromagnetic field. As the current increases, the electromagnetic field increases, and as the current decreases, the electromagnetic field decreases. Changing an electromagnetic field induces a voltage in the coil in the opposite direction of the current. I'll chat about that in a little while. If we look at a wire that has coils in it, we know that there is an electromagnetic field in each coil. Because the coils are so close together, however, they kind of stack on top of each other. There are all these definitions for inductance and how a magnetic field develops inside a coil. And I'm going to give you my explanation as to why this happens. It's probably not exactly the most scientific, but it's the way my mind works. As the current begins to go through the wire, an electromagnetic field is established across the wire as well. And then when the wire coils, the electromagnetic fields start to interact. It takes some time for the coil to sort itself out. There's a magnetic field there, and they're overlapping, and it needs some time to sort out the magnetic field that is there. So initially, when you turn on your circuit, you turn on your current, the coil panics and it needs to stop the current from flowing for the first few seconds because it needs to sort out its magnetic field. As more time passes, more current is allowed to pass through. This is a typical behavior of an inductor in a DC circuit. I was always told never to personify anything in physics, but if your mind works in this way, perhaps this explanation works best. The energy that is stored in the coil is half times the inductance times the current to be squared. And if you want to measure the inductance of your inductor or calculate it, here's a general equation for it. L is equal to n squared mu A over L. A is the cross-sectional area. In the example of my pen earlier, it will be the cross-sectional area here. Or if we slice it down the middle, assuming that it's all the same, it will be the shape of the circle that we see in there, pi r squared. L. Look who got caught doing naughty stuff in here. Yeah. Do you have anything to say for yourself, Bambi? There's one place she's not allowed, which is under the PC, where the wires are. And she loves those spicy wires, especially the Ethernet cable. There's something about the Ethernet cable that she just loves. Isn't that right, Buns? What is it about the Ethernet cable that you love? Want a treat? No? She'll want it as soon as I put her down. Oh. Flick, 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 flick. Oh, she's staying here. Okay, well, she might keep us company, so. Yeah, there's something about the Ethernet cable specifically. She always goes for it. I'm a bunny lawyer and that bunny is innocent. I don't know, Buns. You don't look very innocent to me. Fancy drink. Yeah, it's my go-to cocktail on the weekends. Limoncello, ginger ale, and a little bit of 7-Up. That's my drink. Hope everyone is well. Welcome in, welcome in. All right. I hope you guys are nice and comfy and ready to continue our physics journey, our physics lesson journey. So we're just doing a little bit of introduction to fluid mechanics. Just fluids, because it kind of... What? You want to say hi again? Ah, she's asking for more treats. I just gave her a few pets there. So, as most of you guys pointed out before I left for the little break, the unit for pressure is equal to pascals, but there is a more SI unit we could work backwards a little bit with it. So pressure is defined as force per unit area. Pressure is equal to force divided by area. Okay? If the unit for force is newtons and the SI unit for area is meters squared, Pascal is equal to Newton per meter squared. Now, that's actually a popular unit we use for pressure, Newton per meter squared, in stress. Instead of using Pascal for talking about stress, we use Newton per meter squared. It's just kind of the vibes of the subject. They kind of stick to it. It's just the way it works. Don't worry about it too much. It would be my summary point to that. Now, when we talk about pressure, when we talk about, let's say, Bunzo here, so a little demonstration, Buns. Sorry. In the name of science, Bunzo's donating her her little paws. So if you look very closely to her paws, they're very, very small. So let me just grab a ruler really quick here. Okay. So they're about 1.5 centimeters wide. So we'll say her paws are circular, okay? So she has 4 paws. Obviously her back foot is quite big, but let's say her 4 paws are the same. So she has 4 of those, but let's calculate if they're circular and they're 1.6 centimeters in diameter, which means that they're 0.8 centimeters in radius, which means pi r squared, pi times 0.008, because we needed an SI unit, all to be squared. We grab our calculators, we do some maths here. That is 0.008 to be squared, multiplied by pi. So for 1, paw minus 4 meters squared, and we multiply that by 4 times. Multiply it by 4. She has 4 paws. Obviously her back feet are way, way, way bigger. That's equal to 8.04 by 10 to the minus 4 meters squared. So Bambi weighs about 1.6 kilograms. Is her mass. Now Newton's second law, F is equal to ma. If we want to calculate her body as a force, that will be her mass multiplied by the acceleration due to gravity, which is 9.81 on the surface of Earth on average. 9.81 multiplied by 1.6. And if Bambi was a force to be reckoned with, she would be 15.7 newtons. So now we have a whole bunch of stuff. Pascal, her pressure is equal to the force 15.7 newtons divided by 8.04 by 10 to the minus 4 meters squared. Yeah, Bambi, I'm talking about you. She's just looking up at me at the moment. So 15.7 all divided by 8.04 by 10 to the power of minus 4, close brackets, 19,527.4 pascals. The pressure that Bunzo exerts on the ground that she is standing on at the moment is 19,527 pascals. Isn't that right, Buns? You okay? You're alright. I think she deserves a blueberry. I'll be right back. We're going to get her a blueberry. There we go. Thank you, Bambi, for your time donation in science. There we go. Yeah, is it good? Oh, we got a butt twitch. It's a good blueberry. You can tickle her a little bit as well. Lift you up, guys. There we go. All right. Bye, Buns. You sick of us? This is what is it called? Animal cruelty when you use animals for science. Butt twitch is equal to a good blueberry. Yeah, so if she's eating something really sweet or something she really likes, she twitches her butt. Bananas are amazing. She loves bananas. Hi, Lieber. Welcome in, welcome in. If you stretch your hamstrings, I don't know. That is true. We would be doomed if Bambi was also learning physics in parallel with us. Now, when we talk about fresh pressure in a fluid, you might think that it is a vector. But something to remember about pressure in a fluid is that it is exerted on a point object. It's okay, Bambi. In every direction. So let's say I have a beaker right here, okay? And it's filled with water. Making sure you guys see this, you do? And let's say we grab an object like this and we immerse it in the fluid. What's important to point out is that pressure is the same in every given direction in a fluid at a given depth. So the pressure acting on this block, assuming it doesn't have much height difference, is the exact same in all directions. It's not just squished from the top, it's squished from all sides. I was going to say an important point. If that weren't the case, the fluid would then move. So that's kind of important if this were not true. Now, obviously the block has volume and it has height then. So obviously the pressure felt up here is going to be different to here just due to the height. But for argument's sake, as many things in physics, we think of it as a point mass. So yeah, just to be wary about it. Now, another important property of fluid at rest is the force due to the fluid pressure always acts perpendicular to any surface that it is within, if that even makes sense. So let's do a bit of calculations. Consider a point which is at a depth h below the surface of a liquid. Yeah. Let's take the pressure equation. Pressure is equal to force over area. That's the classical one that we just did with Bunzo earlier. Well, we know that force is equal to mass times acceleration. Are we on board with that? Hopefully. That's Newton's second law if you need a little bit of revision. Well, let's think about that a little bit more. Mass times acceleration. Didn't we cover something with mass earlier? Density is equal to mass over volume. Therefore, mass is equal to density times volume. So we can sub in for that. So we can sub in that part. And A can be subbed in with another letter. There's another letter we can use acceleration. It's very, very specific, which is G, gravity. The acceleration due to gravity. It's the 9.81 usually. Because obviously the force that you experience, sorry, the lighting is blocking some of the parts here. The force that you experience is dependent on what planet you're on. Hi, welcome in, Lur. From Sweden, welcome in, welcome in. So let's sub that all in. Pressure is equal to density times volume times gravity divided by area. This is looking messy, isn't it? Chat, what is volume in terms of area? Volume, if we look at this volume here, if we think about it, is just area by height. You take the area of the container times the height, that's just volume. So let's sub that in as well. Density times area times h times g all over the area. The two areas will cancel and we get an equation for pressure when we talk about fluids, rho g h. And this is a very important equation. Can you replace G according to F is equal to ma to get the speed? No. No, we can't do anything about speed in this case. In some mechanics you can, but in this case, no, we're doing fluids. Hi, Nathaniel from USA, Tennessee. Nice. I need to know where Tennessee is on the map. I'm slowly learning my American geography a bit. That game that we're playing, Extinction Day, really put me on the test because I realized I don't know much. I'm very bad at geography, it seems. We do have V, velocity of fluids, when we talk about fluid dynamics, when the movement, but we're talking about stationary fluids in this case. So the pressure that a body, a thing, experiences is equal to rho GH. It is equal to the density of the liquid you've immersed yourself in. It is equal to G, the gravity, the acceleration due to gravity on whatever planet you're on. Hopefully, most of the time we're talking about Earth. And height, the depth that you're in. This is really cool. So think about this. First of all, it actually matters the pressure that you experience depending on the density of the liquid. So one of the things that we might not consider very much is when people sink. I feel like I've watched Bones, or there's a few not sci-fi, CSI kind of TV shows that I've watched where someone drowns in like chocolate or manure or something. Those things tend to be way, 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 way denser than water. And because of that, if they're under a certain amount of height, depth, they actually experience more pressure on their body because of that. G, the gravity, that stays constant, 9.81, generally speaking. Obviously, the deeper you go into the water, the gravity is going to be affected ever so slightly. But it's so little, it's grand. It's good the way it is. And obviously height. So the deeper and deeper you go into the water, let's say out into the ocean if you're diving, the more pressure that you're going to experience. We're going to show a calculation, but I'm going to hint towards it already, that it's about roughly every 10 meters, you get 1 net atmospheric pressure increased on you. It's a huge amount of pressure that is experienced by our bodies. Middle of the US map and a little to the right, it's a flat-shaped state. We're a parallelogram state now. I understand P is it, but the rest is beyond my scope of classroom instruction. And F is equal to MA. Okay, so you understand why P is equal to FA. Okay? And you understand where F is equal to MA. Brilliant. Why is mass equal to this guy? So you might want to watch the video back maybe about half an hour ago. We covered... Did I leave it on the board? No. Oh? No, I didn't. We covered the topic of density. Density is how compact something is in a certain unit of volume. So metal is way, way, way more dense than wool, generally speaking. Maybe we can compact the wool really, really densely, to be fair. But let's say that. Density of a liquid is equal to the mass divided by the volume. If this is a bit too much, for now, just accept it. But hopefully you can understand that we can rearrange the equation, put volume across on the other side, and that is equal to the mass. We can sub that in for F, in this case for M, density times volume times the acceleration due to gravity. There we go. Now volume is just three-dimensional space. It's length by width by height. Area is length by width. So we have length by width up here, we have length by width by here, they both cancel, and what we're left over is height. That's where this H is left over. Where does the direction for height come in? It's the amount of water above your head. So it doesn't matter if your ocean is 400 meters below you. We don't care what's below you. Below you is not a problem. It's everything that's above your head that's the issue. So when we say height, we mean the amount of liquid above your head, pretty much. Does that make sense? So with more height, the pressure increases. Exactly. So I have a question here, actually. I'll write up the question and give some of you a chance to do some maths, if that's something you guys are interested in. Where's my spray bottle? Ugh. 3D printer still busy in the background. Exactly. But because the area below you and above you is the exact same, those two areas cancel. That's where we get the equation. Now, we're not talking about buoyancy or anything like that just yet. We're just talking about the pressure that the body experiences. And this is something that is really fascinating to me. I'll talk about it because we'll talk about gauge pressure in a little while. But before we get to that, pressure at a faucet. The surface of the water in a storage tank is 30 meters above a water faucet in a kitchen of a house. Calculate the water pressure of the faucet. So, you have a big tank of water like this, and then you have a house over here, we'll say. Oh my god, what is this drawing of a house? Medjay, look away. This house is screaming for help. Ah! Okay, it's on a cliff like this. So the height difference of the water to the house is 30 meters. That's what we've assigned the problem. If the density of the liquid bigger or equal to the object's density, it needs to flow. But if it doesn't, how can I find the normal force? Ooh, sorry, Spin. I don't actually understand your question. Apologies. Oh, I disconnected for a second. Am I back? Am I still here, chat? You have negative height. Sure. Then you'll be calculating delta P by how much your pressure changes. So you could be 10 meters under the water and you could swim up. Then you've changed it to delta H is 5 meters. You can calculate the pressure change. So to calculate this, what the pressure change difference, or what the pressure difference between those two parts, you can use rho GH. The density of water is about 1,000, gravity is about 9.81, and the height is 30 meters. You put that into your calculators, you should get roughly 2.9 by 10 to the power of 5 newtons per meter squared. Or pascals, depending on which one you want to have. How high above the floor is the faucet? That is a very good question.
They call it a mine.
A mine. First of all, thank you so much for the sub. One science, please. Thank you so much for the 3 months. You're very, very kind supporting this channel. Thank you. I'll give you proper problems now. Don't worry about it if I flew through the solution of this one. I'm going to cover a few more bits and pieces. I'm sorry I keep picking my nose. My nose, I think there's snot stuck up my nose. I'm sorry to be crude. And what's happening is it's clearly loose and it keeps tickling me and I feel like sneezing all the time. I'm in a permanent that I don't know if anyone has had that, like a permanent state of needing to sneeze. It's awful. Go up and blow my nose in the next break. Exactly. We need to apply some pressure to get the snot out. Okay, so something that we need to cover now that's really important, and I started slowly hinting towards it, is atmospheric pressure, gauge pressure, and absolute pressure. All of these three things are very different things. Atmospheric pressure is quite literally the pressure that I am experiencing right now. It is the pressure that you are experiencing right now. The atmosphere has a whole bunch of, molecules. Oxygen, nitrogen, carbon dioxide, water vapor. We have a whole bunch of molecules in the air. And at the moment, they're crushing right on top of our head. I know it feels that we don't, like, we're just standing here and like life is good, but we have an immense amount of pressure above our head. I don't know what the number is actually. Let me check. 0.3 by 10 to the power of 5 pascals. That, roughly, is the standard atmospheric pressure on a typical day. Now, weather gets affected by pressure. When you have an area of the world that has a little bit higher pressure, let's say we bump that number up to 1.1 by 10 to the power of 5 pascals, and we have another area that's like 0.99 by 10 to the power of 5 pascals, that is how wind is created. Molecules will move from an area of high pressure to an area of low pressure. And what's the molecules moving in our atmosphere? That's air. So air moves. And so there we go, we have wind. So a lot of the times when we teach this, when we say how wind is created, we usually talk about temperature gradients. But another aspect as to how wind is created is due to pressure gradients. And they both affect each other. And so kind of like chaos theory, it is extremely difficult to predict weather due to the tiny inputs in the initial systems. This can be a little bit of a bitch. But generally speaking, this is what we call standard atmospheric pressure. It's the typical pressure that we have on a normal day. Gauge pressure is... Do I have any gauge pressure at home? I guess not. It's... do you know those canisters of air that you can buy? And there's a little gauge guy on top with a barometer reading pressure on it. That guy is the gauge pressure. It tells you what the, excluding atmosphere, because we don't care about atmosphere, it's always there. Excluding atmospheric pressure, what is the pressure of our container? So that's why you can have zero pressure sometimes. It's like, what? How can you have zero pressure? It's zero compared to atmospheric. So really, the pressure is 1.013 by 10 to the power of 5. My favorite fact is there's always 2 points on the planet that are antipodes, and they have the same pressure and temperature. Really? I didn't know that one. Well, if you remember your theory of kinetic gases, pressure is affected by the number of molecules present, by the volume of the system, by the temperature of the system. So all of these things will affect pressure, and so you get clusters of different pressures in different parts of the world easily like that. And they all affect each other as well. So it's a non-controllable, unstable cycle. Or scuba unit, exactly. So another thing that's important is that that's the scuba unit as well. It's the net pressure, or it's not the net. Yeah, it's not net. Is it net? Yes, you could say it's net. It's a weird one. I wouldn't say it. I'll avoid that term just in case. So it's the pressure reading. What is that called? Is that called a gauge? Or what's that thing that you attach to a air canister called? A barometer? No. I don't think it's a barometer. Yeah, atmosphere can be taught in PSI. There's loads of units. We're sticking to SI. A manometer? I haven't heard of manometer. We'll take it. Barometer is atmospheric pressure reading, though, I think. Regulator? Maybe a regulator. I don't know. Yeah. I'll take manometer. I'm not sure about it, but we're going to assume. Absolute pressure, lo and behold, it's just these two guys added together. So this is the true pressure. So the barometer, or the little machine, the little gauge that is showing you the reading, will be one thing. Then it excludes atmospheric. You're going to measure what the atmospheric pressure is that day, and that'll be another. And that is how you would measure it. So just to show you what I'm talking about when I talk about the gauge pressure, what machinery I'm talking about. I'll show you what I'm on about. Yeah, it says thermos pressure gauge. Yeah, it's a pressure gauge. Just the names that I'm looking for. So this is what I'm on about. It's a little thing attached. The glasses have to make you smarter, right? I don't know. If you think about it, I can't see shit without them. So I suppose, yeah, that makes sense. Otherwise, I won't see the stuff that I'm teaching or learning. I wouldn't be able to do the smart stuff that I do now without them. The classic type is the classic setup where the food column directly corresponds to. Ah, yes. So I know that one. Well, no, never mind. I'll take it back. So the one I was thinking about was the mercury barometer. We teach the mercury barometer sometimes. You know, what is it, like 80 mmHg, that unit, but that's quite outdated nowadays. A lot of kids don't know that, so we did remove it recently. Trying to see works like event to return these wins. Excuse me. Sorry about that. Bless tofu. Thank you. Bless you. Gesundheit. Jesus, I sneezed and I swear I felt my back crack there a little bit. Tire pressure is another common, but they don't tend to use pascals, I think. What units do you guys use for your tire pressures? Well, that sent my cat flying. Sorry, Rob. Apologies. PSI. Oh, bar. So some of you are PSI, some of you are bar. Yeah, I'm not very good at PSI or bar readings. Or millibar readings even. Because I only do the scientific stuff. Slowly but surely, tofu's turning into the physics version of Slavoj Zizek with the sniffs and itchiness. Who? I don't know who that is. It's 1 ATM is 1.013, right? Bar. Is that what it is? Now, what's really interesting about this is that we can calculate some really cool problems with some divers. It's a Slovenian philosopher who sniffs and rubs and nose a lot. Oh yeah? I really think I should go blow my nose. Because otherwise, I'll keep sneezing and stuff. I do tend to get an itchy nose when I have a boss fight or something, though. I notice that's like my body kind of giving in, falling apart a little bit. Okay, let's do a mathematical problem. I might go blow my nose then. Oh, bending to pick up cloth in my old age. I'm an old married Twitch streamer now, you know? An older Twitch streamer, as they say. Older lady. Have we gone through the speed of sound yet? Yes! So I finished the machine. It's printing in the background. Do you see it there? So we're waiting for it to print, but it's a 4-hour project, so it's going to take forever. A senior Twitch streamer. There we go. So chat, I'm going to give you a mathematical problem. Let's grab a giant bucket. And let's grab a lab rat. Not drawn to scale. Okay, so we have a lab rat, and we're sinking the lab rat. We dunk him. Okay, so we dunk the lab rat. Hold your breath, exactly, hold your breath. I'm taking this artistry seriously. There we go. So we have a lab rat swimming in the water. La brat. Would a free fall kinematic problem fit in? No. No, not today, unfortunately. MMHG was silver gauges, right? HG is mercury, no? I could be wrong about that. I don't remember off the top of my head. But I don't think it's silver. I think it's mercury. Poor rat. HG is mercury, yes. So that's what it literally stands for, is millimeters of mercury. Okay. So the distance from here to here, let's say, is 10 meters first. Let's start with 10 meters. Calculate what the gauge pressure is. Calculate what the absolute pressure is. Calculate if I changed it from water to mercury, what would the gauge pressure be? And then, what is the pressure gauge at 20 meters? So those are the 4 questions. I hope you enjoy solving them, but I'll give, if anyone's interested just to challenge themselves, you're free to work away on that problem right now, and I'll put all the solutions, of course, on the board. AG is silver, there you go. Is the rat-sized or human-sized? I don't know. We might need to ask rats. What is the buoyancy of the rat? Buoyancy of the rat does not get affected by this. The buoyancy does not come into play. How much cheese has the lab rat eaten? Also does not affect. If the rat is there at 10 meters, it doesn't matter how much cheese he had. Did the rat have chili lately? Is the rat happy? Okay, we're going down a very philosophical route now. Is it a conical rat or a point mass rat? Point mass for sure. Okay, so to race on ahead, to calculate the gauge, what we need to do is say pressure is equal to the density times gravity times height. The density of water is about 1,000. A good question would have been to say, is that salty water or not? But we'll say it's clear, it's a non-salty water. Gravity is 9.81 and the height is 10 meters. So put that all into your calculators, lab rats and labradoodles. That is 1,000 multiplied by 9.81 multiplied by 10. 98,100 pascals. So at 10 meters in depth of the water, the pressure gauge is 98,100. The absolute pressure would be to grab this and add it to atmospheric. And it is 199,400 pascals is the absolute pressure. This is interesting This means that roughly every 10 meters that you dive into the water, and especially if we change it to salty because it's 1025, it's almost one full atmosphere of increased pressure on the body. That means every 10 meters of depth that you go in under the water, the more and more that your body experiences pressure. You experience double atmospheric. Another 10 meters, triple. Another 10 meters, quadruple. Not logarithmic, it's linear. What I mean by that is that at 20 meters, you experience roughly 300,000 pascals of atmospheric pressure. Now, another interesting thing is that if we remove water and change the liquid into mercury, and we look at the density of mercury, mercury is 13.5. It's going to be 13.5 times more dense. And so just 10 meters alone, oh Jesus, that is crazy. That is crazy on the body. You're not going to survive mercury. Mercury is going to crush you so soon. If you do that. Rip Labrad number 37. It will crush you before you die from mercury poisoning. Or the opposite. Maybe mercury poisoning will kill you before then. Not too sure. That's biology. That has nothing to do with me. Last but not least, what is the pressure gauge at 20 meters? Oh, we did that. So you'd keep adding 98100 each time to that. You add it every 10 meters. So there's a couple of interesting conclusions that we can make from this lesson. So I'm going to bring you down, chat. Bring you down from heaven. As we sit and chat about this, there's some interesting conclusions can be made from this discovery that we just made today. And it is very important, some of the topics that you guys are talking about, hi Nada, when you guys mentioned implosion. So when a submarine goes underwater, it has atmospheric pressure inside the submarine because obviously humans are experiencing, makes sense, they experience classical atmospheric pressure of about 100,000 PA. Now, when you build a submarine and it goes hundreds and hundreds of meters down, every 10 meters it goes down, there is a net increase in the force on the outside. So let's say we take a submarine here. You have 1 ATM, 1 atmospheric pressure pushing outwards, okay? And then 1 ATM pushing inwards. So that's why everything tends to be normal. Structurally, everything is sound from a pressure perspective. When it's on the surface of water, every time it increases in depth by 10 meters, 2 ATM, another 10 meters, 3 ATM, another 10 meters, 4 ATM, and so on and so forth. Every 10 meters that a submarine goes down into water, you increase the pressure that is exerted on the outside towards the submarine. So, when there is a hull breach in a submarine, it's an implosion. What occurs quite literally is you have the submarine, there's suddenly a hole, there's a little gap and hole, and there's overwhelming pressure on the outside, tiny pressure on the inside, and so the big pressure on the outside wins and it squishes in. It's an implosion. In space, when you design a spacecraft or when they're doing spacewalks or anything like that, what you have is you have 1 ATM on the inside of your spaceship, but you have 0 ATM on the outside. So there is a huge pressure difference of 1 ATM, but that's it. There's no more. There's no negative pressure in space in this case. It's just 1 atmospheric pressure. So what happens is if suddenly there's a hole in here, there's so much pressure on the inside, it explodes outwards. You can kind of imagine from this explanation that if you think about it, structurally, it's easier to build take this with a grain of salt, it's easier to build a spaceship than it is a submarine. A spaceship, you only need the material to withstand 1 ATM. Obviously, for safety, you'd probably do a lot more. But a submarine has to withstand way more. And it obviously depends on what depth you want to be able to do. Not all submarines are able to go as deep as they want. There is a limitation to a lot of them. Sorry, I ended up talking a lot there. Oh! And for some reason, I ran ads. That was a complete accident. I'm so sorry. Why am I running ads? Did I press something? Oh man, I'm so sorry.
A mine.
I was into explaining stuff there. Hi, Helix. Thank you so much for... Sorry, you've been here the whole time. But thank you so much for the sub. Really, really appreciate it. We really appreciate the PP points. When you guys sub, it helps me get a better share of monies from Twitch. So I really appreciate the subs. Thank you. So if the pressure above the submarine increases as it goes deeper, can systems be built to balance the pressure inside the submarine by increasing the internal pressure? But then the humans would be experiencing that same pressure. The humans can't withstand that pressure. Our bodies aren't able to do that. What role does gravity play in this? Well, depending on the depth, it's the sheer net value that it's going to affect. It's about 10. So if gravity wasn't an issue, we'd minus 1, 0. It'll be only 9,800 pascals every 10 meters we go into the water. But because it's about 10, we add another 0 into it. So that's why every 10 meters is roughly 1 atmospheric. But it's a good point to point out that if you were swimming on Mars, for example, Mars only has 1/3 of the gravity. So you could go deeper into the water of Mars because your body pressure could withstand triple the depth. So that's an interesting kind of thought about it. What about YouTube monies? As in on YouTube, I recently became a YouTube partner. I don't know if you guys can give YouTube's monies. I'm not sure if it's set up. What is the background music? It is Surviving Mars OST. It's one of my favorite games I used to play. Or does pressure exist because of gravity? Yeah, no, that is it is the gravitational force of keeping the atmospheric particles on top of us, and like why the water doesn't float away. In that case, that is one way of looking at it. I'm so sorry about running the ads there, by the way. I really didn't mean to. Yeah. What book are you using? So this is a textbook I use. It's Giancoli. But sorry, all of these problems are not in the book. This is something... So sometimes I use a textbook to reference things, but yeah, none of this is in the book. So just bear in mind that the last hour is not. But this is just a textbook that I'm referencing. But I think any general physics book is fine. And I have no attachment to this book. Any general physics is fine. It's okay. I love ads. The world has made us love ads. So if there's water on Mars, and if we start doing space tourism, scuba diving on Mars would be pretty fun. That's a conclusion that you can make from that statement. Yeah, that's true. There could be a lot of fun to be had. Faux show. The water doesn't float away. On Mars, no, because it still has gravity. Mars still has gravity. Any body, by definition of Newtonian laws, any body does have gravity. It's just if you're very, very small, like me and you, we don't have much of a force of attraction between us. Sorry to burst your bubbles. But planetary bodies do tend to kind of stick together a bit. They do have a force of attraction between each other. I would have loved to be able to have an... Oh, listen, you still can. You absolutely still can. I didn't know about this when I was younger and in school, honestly. I mean, it depends what you say about younger. In the kid ages, I didn't appreciate nor understand much of this at all. At all. So I will always try to advertise it's never too late. As everyone knows on stream, with all my coding, 3D printing, and all the electronic projects, and even physics, there are so many things I learn every stream. Learning never stops. I do recommend to never give up if you can. Obviously, if you're interested. I wonder if you can do layered hull with pressure between each layer moderated. It sounds like very energy inefficient. I know what you're saying, but I wonder... I'd have to think about it from a structure perspective. How do you get into science? I'm starting college. Well, I don't know. Everyone gets into science weirdly. Like I told my story, I got into physics accidentally. Life finds a way. Shit happens. Now we're here. Have you done a video on impulse, collision, and bounce? No. I struggle for a long time with impulse as well. It's a weird one. It's really weird. I'm not the biggest fan of impulse as well. It might be something for me to sit down and look over again. Usually the videos that I do are original in some sense. When I record a video, my YouTube videos, usually it's because I have an aha moment. I'm like, oh, wait, I get this because of A, B, and C. And the A, B, and C is something original. So even though my video could be 50 minutes long talking about alpha, beta, and gamma particles, there's something about it that makes it unique. Or the lesson that I teach makes it unique. In this case, just a couple of weeks ago, I uploaded about the radium girls. So I was interested to understand actually what happened to the radium girls, like from a pure physics perspective. And so that's how I ended up teaching it. Or when I teach about capacitors and inductors, even though I gave a 10-minute lecture on what a capacitor and an inductor is, I gave my instinctual explanation as to how they work by giving them a bit of a personality trait. A bit weird again, but it's just all these little things. So with impulse, or if you want me to do a topic on a video, I need an aha moment. I need a eureka moment. I need some moment of, oh yeah, that's class. I get it now. And I want to do a video. Because otherwise, I think there's loads of YouTubers out there who make great content and great educational videos and great websites. Nathaniel, if you want to check out, I literally have a YouTube video on that topic, the new one that just got uploaded, on how to learn physics. So in the mathematical case, I would say it's better to understand than to learn off. If you're interested, it's about a 10-minute video. Even less, I think, 6 minutes. I don't have a video on ceramic versus electrolytic. I don't know, I've never gotten interested in that. I could, definitely could get back into that a bit. They're very similar, impulse and momentum, but not exactly the same, Nathaniel. Yeah, they're a bit weird. I guess the reason why I think impulse is better to understand via calculus rather than algebraically. I could be wrong about that. Take what I'm about to say with a grain of salt. And no worries, Spin. Thank you. Thanks a million for hanging out. Really, really appreciate it. Appreciate everyone and anyone hanging out. Yeah, Professor Dave, I've seen a few of his videos. I'm a big fan of the chemistry tutor. He does some great videos, mathematical problems. Exactly. And it's so satisfying as well, Revak. Like, it's kind of, like I said, a bit like programming or anything like that when you get those eureka moments, aha moments. But again, for me, programming is an illusion. I think I like programming because when I get to solve something, I feel good about it. But then I realize that actually it's just trauma. It's, yeah. I'm lying to myself that I enjoy that. Really, it's just like you're traumatizing yourself so much that when you do get a grain of positivity in your life, you yearn for it. It's a toxic relationship if you think about it. Programming is. It's kind of like that guy that you date who is so mean to you and so disgusting, and you're like, oh, maybe you should break up with him. But then he says the nicest thing out of nowhere and buys you flowers, and it's like, oh, I love this. I want to achieve this more often, and you stay in that toxic relationship. There we go. That's what programming is to me. Impulse calculations and figuring out how a shockwave worked through some structure. I tried to do some physics on shockwaves and I struggled, so maybe that's what I needed to learn to be able to do it. As a programmer, I'm offended. Is there a science communicator YouTuber that you would want to collaborate with? Ooh. I mean, surely people like Veritasium and stuff would be class. But do you know, realistically, who I'd love? Is Kathy Teaches Physics, I think is her YouTube. Kathy Teaches History Physics. I'll show you her YouTube channel. That would be a collab that I would love to do, but also like, yeah, Kathy Teaches History Physics or Kathy History Physics. There it is. Kathy Loves Physics. Sorry. So if you're like me, like you do study a good bit of physics already, her videos are so awesome to watch because she gives a lot of historical context to the lore behind equations being developed and stuff like that. So yeah, I enjoy her videos, and she does quite original research as well. So that would be a YouTuber that I recommend personally. And she is quite a big YouTuber. I don't want to take away from her, but she's not as massive as Veritasium or Kurzgesagt or anything like that. And I think she does everything herself. Her research is herself. The editing is herself. Yeah. Yeah, Kurzgesagt does nice fluffy pieces. They get a lot of people interested in science a little bit, which is cool. I think these channels, I used to be a bit, not mean, but have slightly negative outlook on them because they're not actual physics stuff. But if we keep looking at things like that, then physics is never going to be attainable for anyone, you know? And popular science isn't going to be available. And there's a reason why it's called popular science. So you know what? I've changed my mind about that. That's something that I've abandoned, an opinion I've abandoned over the years. I think Kurzgesagt and all those kind of YouTube videos where they do fluffy science pieces is quite needed. And it's good that those channels exist. Obviously, don't have an illusion that that's what you do if you do a physics degree. Please don't have that opinion. I think that's the usual issue with those things. But I think they're great channels now. Kyle Hill, yeah. I follow Kyle Hill. It explains how pressure coming out of a muzzle brake can damage the human body if you're a 30-degree angle from the front of it. Oh yeah, so sine of theta can affect can affect a lot of these kind of things. I think that's an experiment students do in mechanics, is determine the optimum projectile motion, optimum projectile angle to throw something. Good day. Hello, Kira. Welcome in. Hello, Robert. Hope you're all keeping well. I love your t-shirt. Thank you. It is my custom merch. And you have a cat at the back as well. Ugh. But it's an empty box. No, I don't do any theoretical physics. It's a bit weird to say that, I would say. It depends what you mean. Like, do I study relativity, particle physics, and those kind of realms and space stuff? No, I don't study, nor do I teach it. So I have no interest in those kind of things. I've never really had an interest in them. In my early days I did, but then I fell in love with classical. I always advertised myself as a classist. But I think what was weird was about the TV show Big Bang Theory. I think people got a weird illusion about physics. So in the Big Bang Theory, you had Sheldon, who was the theoretical physicist, and then Leonard, who was the experimentalist. And that's how they introduced themselves. I'm an experimental physicist, he would say. But that's not how physicists or scientists classify themselves. So if you asked, oh, I'm a physicist, and they say, oh, what kind of research do? You would say the realm, as in like, Sheldon should have introduced himself as a string theorist, right? So he does a lot of string theory. And then I'm not actually sure what Leonard did, because Leonard did a lot of experiments, if I remember. Leonard did a lot of stuff, which was odd. And I think that was the issue I had, is that he knew too much about everything almost. You can't expect too much accuracy. No, true, but I think a lot of people just had this weird illusion that, if you're a physicist, you classify yourself into those two categories, and it's not. Because usually you classify yourself in a field, and then you're both an experimentalist and a theorist. You do both of those things, usually. What realm of research do you do is a weird mix of... Is it? What has been the most difficult part of physics for you? Maths. So I was actually not a bad maths student, generally speaking. I was always above average. But the maths in a lot of the physics, especially like understanding concepts in mathematics, was always a struggle for me. So things like Taylor expansion series and why we have that and why it's used and why did you even bother with that kind of thing, and that kind of stuff is a bit weird to me and always has, and I kind of struggled a lot with that when I was younger. But yeah, with a lot of those things you kind of have to just practice and treat them as a tool. Hi Feynman. He was outstanding in his field. Not bad gambling, not bad. But yeah, there hasn't been a subject that I have properly struggled in physics. Anything I've been given, I've tackled. So... yeah, Zir, that is just so broad. It's so weird, that description. So he wouldn't have he shouldn't have introduced himself as a particle as a experimentalist. He should have introduced himself as a particle physicist. That's what you would do. It's weird. It's weird. Do you have an end goal, or do you just continue with your interest? I think I kind of reached my end goal as of recently. Okay, that's a bit of a stretch. I think I always create goals. I have a problem where I create goals for myself and I achieve them. I know, life is so difficult for me. But I don't tend to celebrate them. I tend to move on very quickly. It's like, okay, what's the next thing? What's the next thing? I noticed looking back that I didn't get a chance to celebrate a lot of my goals. The little personal self-reflection that I've done recently. Kind of sad. Because I've achieved a lot in life, the more I think about it. But I don't advertise it too much. Sometimes on Twitch. I feel like Twitch is the only place I advertise my achievements. Y'all are the only ones I ever talk to. What was your last goal? To become a full-scale lecturer. So I've reached the cap of my career. Pretty much a month ago. Have you created? Nah, I'll leave that to Jeff Goldblum. I love The Fly though, it's really good. Have you gotten into the math proof of what? Yes, as in like I don't understand it, but I have seen it. Cause like I love reading a comment of someone in response to me. This is as basic as 1 + 1 = 2, and I love citing the publication to back it up. Oh really? Is it that simple? Do you want to check this out? By the way. No, what did Archimedes say before he was killed? Don't say that. You can make professor. Professorship is weird. I can be prideful in the sense that I'm a good teacher, but I'm not an amazing researcher. I don't have research funding, loads of postdocs, loads of PhD students. So for professorship, I need to do a lot of that for about 10, 20 years. Solid 20 years of a research career before I can apply for professorship. That's not even an unrealistic goal. It's just something to, like, I could give birth to a child and raise it to go to college before that professorship is even available for me to apply. Do you know what I mean? Like, that's how crazy that goal is. Don't disturb my circles. I don't get the joke, Feynman. Yes, it's the Irish standard for I think it's like almost the European standard as well. I could be wrong about that, but it's so in America you can become a professor just by being a lecturer. It depends on the university, but in Ireland and a lot of parts in Europe, it is a huge qualification. Enjoy the rubber duck, Nathaniel. Oh, that's right. He was trying to find the value of pi. There we go. It wasn't a joke. I thought it was a pun, and I didn't get the pun. I thought it was a dad joke. What was I watching recently where that was shown? It was some movie. Was that in Indiana Jones? Am I crazy or am I thinking of something? There was an Indiana Jones movie. Was that Archimedes on the beach? Am I right or wrong? Probably wrong. .4. We have assistant professor, associate professor, and full professor. Yeah, we have that system has just been implemented like 3 years ago. It's quite a new system, Phantom. But yeah, so even though we have the term associate professor, so my equivalent is associate professor, I believe. But we still don't call. I don't think you're allowed to call yourself a professor. I could be wrong about that. Maybe I'm spreading rumors. I might be wrong, but I don't think you're allowed to call... Like, you can't have the title PROF unless you get the full professorship in Ireland. Unless it changed. Again, this could be a very changing phase in the last, like, year or two. I know that they want to implement it. Associate... No, I don't think so. Yeah. Bear in mind that, of course, it's dependent on every university and every country and every department. Everyone does it ever so slightly different. So it is to be, yeah. So I don't know. I know a lot of people say that, like, there's tenure. We don't really do tenure in Ireland, but we have full-time contracts. So basically, no research or research. I have a permanent position in my university. I can get fired if I do something illegal, like break my contract. But I have a permanent contract. They can't fire me for other reasons, only for, you know, for me being bad. So does that mean I have tenure? I don't know. You tell me. But I feel like that's just standard. Most jobs in Europe are kind of like that. So as long as I'm a goody two-toe shoe and I behave well. What is the timer like beeping? Oh, that's probably the 3D printer. I'll show you now. Lecturer is the 4th rank, and very rarely I'd see lecturer as part of the main faculty. It's always PhD students or new academics. Do professors do much research? They can, yeah. It really depends. Some professors are extremely hands-on with their students and their research, and they can be very good. Some are not. Everyone is very, very unique. Do you like Cillian Murphy? Of course, he's great. I liked him before it was cool to like him. I liked him since 28 days. Hi, Evandriel. I liked him before it was cool. So, I know we were kind of just chatting there for about 20 minutes or so. Hopefully it was a little bit of fun. But I think our spaceship isn't going to spaceship itself. You know what I mean? In Elite Dangerous. So what we might do is we might say goodbye to YouTube. Thank you, YouTube, for participating and asking all the questions. But we are finishing the science segment of the day, so we'll see you guys next week. To the YouTube people, I will be streaming next week, Saturday, Sunday, and Monday. Yeah. Is that the Schrodinger? It is, and it's a cat in a box, and the cat's box from the back. It's from my merch store. Medjay drew it.